Okay, guys, this is June 2023 exam. That is for grade 11 mathematics paper 1. And we are going to see 2 hours for this paper, a total of 100 marks. That was our question paper. We are going to check what are we given. So be careful in the simplification. Make sure that you read the instructions and the information that you are given. Everything, especially on the issue of the rounding of your final answers to 2 decimal places, unless stated otherwise on that particular question. And also diagrams, they are not necessarily drawn to scale. The number of the questions, that is the answers correctly according to the numbering system used in this question paper, and also everything must be neat. So this is what you are going to have. Make sure that all the calculations are properly presented where calculations are needed. All right, question number 1, without wasting your time, we are given 1.1. If x is an element of, meaning to say x is of these values only, that is 0, 1, 2, 3, 4, and 5. These are the x values that we are going to focus on, only these. Determine the values of x from these values that are here. Determine the values of x that when you substitute here the value of x, 1.11 is not defined. This one is a natural, this one is an irregular. So they are simply saying, substitute the value of x, any value of x here that you're given, and see where it is not defined. Okay, that is the case. So if you are someone who is into like calculations, you can see that, okay, I'm dealing with a fraction there. Yes, it's a square root. I know that I'm having a square root there. And I know that the square root cannot be of a negative. So the square root of a negative value does not exist. This one does not exist. It is not there. We do not have the square root of this. So what it simply means is that, all right, I want you to do this so that you understand me. This is you and your calculator. You are going to say that, all right, let's just try the square root of a negative 5. That is math error. This is to show that this does not exist mathematically. A square root of a negative does not exist. So the question is, where are we going to have this as a negative? That's the question. Where are we going to have this as a negative value? Where are you going to have it as a negative? Where you have it as a negative, that's the x value they are talking about. That is the x value the question is referring about. Okay, so this is just a substitution that you are going to make. So I just want you to see something so that we can properly answer this question quickly. So you just substitute your values. If you do not know, just substitute, because you know that not defined means cannot be simplified. So this is the square root of 16. So you just put your fraction. Already you have your x value. So you just have to substitute 4 minus the first value. It's a 0 there. So if you check, you have got an answer there. You move on to when x is a 1, you substitute a 1 there. You see that there is an answer there. Guys, not defined means there is no answer. This one is an answer. It's a decimal, whatever that you have there. That's an answer, meaning to say it can be defined. When x is 2, we move on to 2. This is going to give us this 2 squared. All these values, they can be simplified. All right, let's move on to 3. We put on a 3 here. That's a 3 in place of x. That's a 4. All right, meaning to say it can be simplified. We put a 4 in this case. That's all right. If we put a 4, that's 4 minus 4. Meaning to say this cannot, as long as it gives you a math error like this, it means it cannot be defined. So if you do not know, that is the way that you can use. So meaning to say in this case, our x must be a 4. All right. Let's move on to another x value again and see. All right, if you do the same when x is a 5, you substitute a 5. This is going to give us again a math error. I mean to say this cannot be simplified when x is also equal to 5. So these values of x that we have in this set that we are given of x, these are the values of x that will give us something that is not defined. So since we have got x, which is 4 and 5, you can also write it this way. X is going to be an element of the numbers that are going to represent x. It's 4 and 5, just like that. All right, so this was your condition. When this is a natural number, so the question is, what is a natural number? A natural number is a counting number, excluding 0, meaning to say 0 is not supposed to be there. So what I want you to do is to substitute. You're going to substitute when x is the 0 there. You're going to substitute, meaning to say that's where you're going to have that 4 that we had. So, okay, guys, we talked about these values. So you are going to see that where we're going to have exactly the counting numbers. That is when our x is a 0. We saw that time when we substitute a 0 there, we got a 4. So meaning to say x must be a 0. Okay. Also, when you substitute numbers such as 1, 2, you saw we got the square root there. Okay, if we move on to 3, we got a 4 again there, meaning to say a 3 is going to give us a counting value if you substitute this. So I want you to substitute a 3 and see what you are going to have at the end is a counting value, because we saw previously that this gave us a 4. A 4 is a counting value. We saw that at 4 and 5, then this was not defined. So it can't be a natural number, because a natural number is a counting value. So we can't use the 4 and 5. So this is the only part that we have. All right. Then when this is an irrational number, remember, an irrational number is just the opposite of a rational number. A rational number is the one that we are used to. A rational number is the one that you express as a fraction of the form of a over b, where these are all numbers and b cannot be equal to 0. So meaning to say we just want a condition where we are having that is an rational. But now they're saying this is an irrational. So it's the opposite now of this. Meaning to say irrational, that is when we are having those square roots. Now the square root of 3, the square root of those square roots that we're having, those are irrational, the opposite of a rational number. So we can't use this 4 because it gave us a natural number. A natural number cannot be any rational number, because a natural number is a counting. So where x is a 0, we saw that it was a 4. You're not going to take that. So the value was going to be at 1. Remember, when you substituted 1, guys, I showed you, we saw something like 4 square root of 3 over 3. That's an irrational number. So meaning to say, at this point, our x must be at what? Our x must be at 1. We also saw this happening when we substituted a 2, we got 2 square root of 2. 2 square root of 2 is an irrational number, but we got this from which value of x? When our x was at 2, when this x was at 2. All right, if you move on to these 3, when x is 3, it was a natural number, so it can't be an irrational number. When 4 and 5, these are not defined, so meaning to say these are the only numbers that will give us an irrational number, an irrational number. Be careful. You have to substitute. So when it was like this, you had to substitute so that you see these numbers, how are they? So this is your grade 10. Remember your grade 10 maths on those numbers. I want you to also revise that part so that you have an idea. So this is just 6 marks for that. All right, let's move on to the other part of our question. 1.2, solve for x. So 3 marks for the first part. 1.21, we are given to solve for x. That is 1.21, we are given. This is 3x squared minus 4x, which is equal to 0. And that is 3 marks for that. All right, that's a quadratic equation. And the fair part of this quadratic equation is that there are just 2 terms. We know from our factorization that if there are 2 terms, I can just factor out the highest common factor, which is x. By factoring x, I can divide 3x squared to x. This will be 3x minus 4x to x. That will be minus 4. That's equal to 0. Remember, from the 0 concept, one of these from the product must give us a 0. So it's either x, it must be a 0, or the bracket of 3x minus 4 is equal to 0. So from this, if we are to solve for x, transpose this to the other side, that was going to be a positive 4. Then you divide by a 3. So meaning to say x was going to be a 0 or 4/3. You can use a quadratic formula if you want. That is your choice, but that is 3 marks for that. All right, so for x, 4 marks. So if you see these 4 marks, in most cases, we know that it's going to be a quadratic formula. All right, so we have to apply our quadratic formula, completing of the square method. It's your choice again. So this is 1.12, where we are given 3x minus 14 is equal to minus 6x squared. So the first thing is the format of our quadratic equation, which must be in the form of ax squared plus bx plus c is equal to 0. So if you have to check this format, we can transpose this because what we need is to have one of the sides equal to 0. So transposing minus 6x squared to the left-hand side makes this one to be a positive. That's 6x squared because it has crossed the equal sign, so the sign changes. Plus 3x minus 14, which is equal to 0. So as we can see, we have our normal quadratic equation that we can solve using our quadratic formula from the format of ax squared bx plus c. It means our a is 6, our b is positive 3, our c is the constant. So using the quadratic formula, we know that our x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. That's going to just substitute b. So that is minus b, which is positive 3, plus or minus the square root of b, which is positive 3 squared, minus 4 times a, which is 6, and our c, that is minus 14. All right, that's a minus 14. Then you're going to divide everything over 2 times a. That is 2 times a, which is 6. So what I would like you to do is to at least try to simplify this part that is under the square root. Just the part under the square root. I know you can simplify this direct. I know that you can do that. I know that you can do it. But just simplify, try to just simplify this part here under the square root, this part alone. Don't put any square root, don't put any, just these numbers under the square root, these ones. Don't put anything, just those numbers under the square root. Just try to simplify that part alone. Okay, this is what I'm trying to say. This is your calculator, so you're just gonna see what I'm trying to say here. So this is it, the numbers that are under the square root only. So there's a bracket there, 3 squared. All right, so we're gonna have 3 squared. All right, minus, so the calculator is not as fast as I am. Just hope this calculator was so fast also. Anyways, this is it, guys. What I just want you to do, the numbers under the square root only gonna obtain 345. So meaning to say from these numbers, we are having 345, everything over 2 times 6, which is a 12. Then from there, you can separate. I don't care how you're gonna do that, but at least we see this number. Try to do that. All right, then you're gonna separate plus or minus. So this is what you're going to have on your calculator. Even if you don't show that, just write your answers, no problem for that. Minus 3 plus the square root of 345, everything over what? Over a 12. So this was going to give us this, then pressing this SD is gonna be 1.29. So to 2 decimal places as we are given on the instruction of the question paper. So you can do that on your calculator. Shift, you go to the setup. So this is fixed on number 6 there. Press 6. It can round up to any decimal place from 0 to 9. So we want 2 decimal places, press a 2. So change again. So that's 2 decimal places, 1.30. So that's 1.30, or x is equal to, again, you go back and change this to a negative. All right, so already our calculator is fixed to 2 decimal places. That means whatever that I'm having is to 2 decimal places, which is negative 1,8, 1,80 to 2 decimal places. Make sure that you follow the instruction that you are given. So in this case, we are not given the instruction here. We use the instruction that we saw from our information sheet to 2 decimal places. So these were the possible values of x which satisfy this quadratic equation. All right, let us move on to another part, which is 1.23. Solve again for x, and that's an inequality, which is 4 marks for that. All right, so there we are given an inequality, 4 marks. Let us see how we're supposed to have this inequality. Thus we're given 1.23. The bracket of x plus 1 into the bracket of x minus 3 is greater than 12. So that is the idea there. So if you have to simplify, if you have to solve this inequality, we know that we're going to need the critical values. But before that, the same thing that we are talking about, this is, if you check, there are two brackets there. So by expanding these two brackets, we can see we're going to have a quadratic. So at the end of the day, we're going to have the same format, just like what we had on this part. It was a quadratic, yes, but we had to also focus on the format. So the format also plays a role. The format also plays a role. So you're going to expand brackets, then this, you have to transpose it to the left-hand side so that we remain with a 0 on this side. All right. So expanding our brackets using our FOIL method, x is going to multiply with x, that is going to be x squared, x times minus 3, that's minus 3x. Make sure that x multiplies everything in the second bracket. Then 1 multiplies also everything in the second bracket. That's 1 times x, which is positive x minus 3. All right, 1 times minus 3, that's a negative 3. So if we were to transpose the 12 to this side, because it's a positive, it was going to be a minus 12 that is greater than a 0. Transposing this does not affect anything. It doesn't affect anything, it does not affect anything. So meaning to say, what we just need is to have a 0 on one side of the inequality, just like what we had on a quadratic equation. So this is x squared, collecting our like terms, minus 3 plus 1, that is going to be minus 2x, minus 3, minus 12, that is going to be minus 15, is greater than 0. So at this part, you can talk of the critical values, which is fine, or you can even go on to the factorization before the critical values. It's up to you. All right, since this is a quadratic, having the coefficient of x squared as 1, it means we are going to have x in this bracket, x in another bracket. Then you consider the factors or the products of minus 15, the products of minus 15 that will add up to negative 2. There are so many numbers that you can put into consideration, minus 5 and 3, 5 and minus 3. So where are we going to have a negative 2 if we add? If you multiply, you get a positive, which a negative 15, which is fine. If you add, you obtain a negative 2. If you add here, you're going to obtain a positive 2. So the part that gives us a negative 2 is on the minus 5 and the positive 3. So meaning to say, on this bracket, we are going to have minus 5. All right, this one, we are going to have a positive 3. So that is where now you can think of the critical values at this condition. The critical values, what is it that you're talking about? These are the solutions of an equation, not an inequality. No. No, not an inequality, an equation. Just like you are having a normal equation, you take it as a normal equation, x minus 5 into the bracket of x plus 3 must be equal to, it's now an equation. These are the points, the solutions that we have when our function is equal to 0. Add the critical values, these are the solutions direct. It's an equation, this one. So remember that from the 0 concept, one bracket must be equal to 0. So it means x was going to be a positive 5 on the other hand, or x was going to be a minus 3 at the other hand. These are critical values. Then from the critical values, you now need the absolute solutions, which is the exact solutions of the inequality, not the equation. The critical values are of an equation. An equation is an equation that's here. This is an equation where there is x is it. There's a 0 there. X is equal. There's an equal to. Whether there's a 0, whether there's an equal to. The moment there's a inequality side there, it's no longer an equation. So we took something that is not part of our question. These brackets here, they are not part of our question. I mean, this bracket is equal to 0. To equate to 0, to say is equal to, this is not part, because it must be greater than, not equal to 0. No. So that is why we call these critical values. So from there, you need the solutions. You need the solutions. So how are you going to determine the solutions? That is the question now. That is the question. That is, how are we going to have these solutions of the inequality? Whether you're going to use your number line, you're going to use the graphical method, it's up to you. So using the graphical method, this is what you do. You go back at this stage. As we can see, the coefficient of x squared is 1, which is a positive. And we know that if it is a positive, A is a positive, you're going to have a smiley shape like that. So that will be a smiley shape at a point where this function crosses x must be 5 or a -3. So -3 will be on the left side and a +5 on the right side. So representing or talking about the x values, these are the ones that we need on our solution. Where is this function greater than 0? Where our function is greater than 0, it is when this function is above the x-axis. Above the x-axis. That is when it is greater than 0. When it is less than 0, that is when it is less than 0, that is when it is below the x-axis. When it is like that, you have to consider that it's below the x-axis. So it can be a condition like that. It can be a condition like that. When it is less than 0, you consider something below the x-axis, below the x-axis. That is what you need. So each part you have to be very, very careful. Where is it that you're taking your solution? So in this case, we are talking about something that is above the x-axis, that is a positive. So above the x-axis, our solutions can be this side of our function or this side of the function. We cannot take something that is open like that. Just like here, there's nothing. What are you? What is it here? There's nothing there. So our values on this side, always you take a less than. These values, they are less than -4, minus whatever that you have, -1000. They are less than this value that you're given. That is less than what? -3, or our x values on this side, they will be greater than the value that you see here. Always it will be greater than that value that you're going to see there. I just hope I talked about this on the inequalities. If so, if not, we're going to talk about this introduction so that we do not waste much time when doing question papers, but I just hope you understand the concept. So in short, this is what I want you to do. Whenever you have got these solutions, all this side, they must be greater than. And also you consider here, if there is an equal to here, let's say there was an equal to there, you also do the same thing on your answer. You also put what? An equal to there. But in this question, there is no equal to. You just put greater than, just like that. If the solutions are within here, let's say it was a less than, and these solutions are here, these are the one that you want. How do you present this region? This region, always, it will be x is greater than or x is less than these numbers on the boundaries at the critical values. So it will be greater than the lower value, which is -3, less than the bigger value, which is 5. Always, never have these signs interchanging, or you see these signs facing each other like this. It won't be like that. It will always be like this. X is bigger than that smaller value, but x must be less than what? Your bigger value. That is the condition. Always. So if also there was an equal to here, you also put an equal to on your what? On your answer. But in this case, it wasn't like that. So I'm just saying this because of time. But on our introductions, we hope that we're going to talk about this. If we talked about this, then it's an advantage. All right. So that was the question of the inequality. Then we move on to another question, which was 1.24. Again, solve the equation. This one is an equation. We are solving for x. It's an equation because we have got an equal sign. That's 4 marks for that. I'm just going to rewrite this equation. So we've got 4 marks there. So 1.24, you are given the square root of 2 minus x plus 2, which is equal to x. So these are sets. You are working with the sets like this. How do we solve these sets where there's a square root? What you need is to make sure that you remain with a single set on one side. you must have a single set on one side of the equation, meaning to say I have to get rid of these 2. 2 is not inside of the square root, it's just a number added to the square root. So we need to remain, or we need to have a single set on one side of the equation. And this is our set, this one, this part that is under the what? That is having the square root. So we need to make that the subject. So we are going to have the square root of 2 minus x is equal to transpose 2 to the other side. So it's going to be x minus 2. It was a plus. So on the other side, it will be a minus. So how do I get rid of this by having a single set? I square both sides. By squaring both sides, you are removing the square root. All right, so the square and the square root neutralizes. So meaning to say, we are going to have 2 minus x, which is equal to x minus 2 squared. And x minus 2 squared, you're going to expand. So we're going to 2 brackets x squared minus 4x plus 4. So you can use your identities, or you can expand brackets as usual. There's a bracket of x minus 2, a bracket of x minus 2. So x and x, that's x squared, x minus 2. Minus 2 and x, minus 2 and minus 2. That will be a positive 4. So these add together. That will be x squared minus 2 minus 2. That's minus 4x plus a 4. You can do that. This one is up to you. Or you can just use your identities. Remember, we know that a minus b squared is equal to a squared minus 2ab plus b squared. So we can also use that, which is the one that I just used there. You can just use it in your head and expand. A quadratic equation, we saw that in the previous case that we're supposed to have the format of ax squared plus bx plus c, which is equal to 0. So having this, we can transpose this so that this side remains as a 0. And this is where we have a lot of terms. So it's better that we transpose these terms to the other side of the equation. So that's 0 is equal to x squared minus 4x. So if I transpose the minus x on this side, it will be a positive x. Okay, the sign changes. A 2 will be a minus 2. So that's 4 minus 2. So that's 0 is equal to x squared. If we add this, what are we going to have? Minus 4 plus 1, that is minus 3x. 4 plus 4 minus 2, that's a 2. We are used to this simplification. So from there now, we can solve our equation, knowing that if A is equal to B, it means B is equal to A. So this does not stop me to take this and write it on the right-hand side, on the left-hand side, without affecting anything. It does not stop us to do that without affecting anything. Without affecting anything, we can do that. So meaning to say, at this stage, you can use your quadratic formula. That one, it's up to you. You can use your factorization method. So in this case, I'm just going to use the factorization method, taking advantage that the coefficient of x squared is 1. So it means one bracket must be x, another one x, so that if you multiply x and x, we've got x squared. So taking the factors of positive 2, factors of 2, and these factors must add up to minus 3. Since this is a positive, it means we are supposed to have our numbers as negative, all so that we get a negative. This one is a negative, this one. So if you have minus 2 and minus 1, you multiply, you get a positive. But if you add, you get a minus 3. So these are the numbers, minus 2, minus 1. So from this, x must be equal to what? A positive 2, or x must be equal to a positive 1. So these are the x values that we have. But as long you are working with a said equation, test your solutions. Does this make sense? Does this make sense? If x is equal to 2, does this make sense? If x is equal to 1, does this make sense? Okay, this is what I'm trying to say. If we are to substitute the x value that we had, the first value that we had there was positive 2. All right, so this is it, what you're going to have on your calculator. Remember, we fixed our calculator last part to 2 decimal place. So let's just go to the normal function, 8 So you're going to press 2. All right, so this is it. The square root of 2 minus x. So this is 2 minus x. When x is 2, all right, then we move aside. There is a plus 2 also there, plus 2. This is going to give us a 2. All right, so we are saying this is 2. The left-hand side gave us a 2. When x is what? When x is 2. On the right-hand side, there's x. We substitute a 2, so x is 2. So 2 is equal to 2. This is good. This is correct. Okay, let's move on. When this x is 1, remember another solution is 1. We substitute a 1 here. This will be the square root of 2 minus 1 plus 2, which is a 3. So this is giving us a 3 when x is a 1. We get a 3 is equal to, when x is a 1, you substitute a 1. 3 is equal to 1. No, 3 cannot be equal to 1. So meaning to say, when x is equal to 1, this is false. So x cannot be equal to 1, but x can be a 2. So always when dealing or working with a set, unlike any other quadratic equation that we are having here, where we never tested our solutions, when you are working with a set, you have to test your solutions at the end. Does the value of x that I'm given, does it satisfy the condition that is given? That is the case. All right. Number 1.25, which is if x minus 6 is one of the solutions of the equation, this equation, determine one value of y for which this must be equal to 16. So these guys, they are just playing around. They want to confuse you here. Take note. X minus 6 is equal to 0 is one of the solutions of this. Take note, this is x, this is 40 over x is equal to 16. Now they're saying, determine one value of y for which, take note what is happening, 2y. Take note, this is 2y plus 3. If you check the way that it is given as 2y plus 3. 2y plus 3. There's something that we are supposed to just have a single term x. Where there's x here, look here, guys, look here. This one, this 2 minus y here, is in place of x plus 40 over x. It was x here, but look here what they put. In place of x, they put what? 2 minus y again. This 2y plus 3. The same 2y plus 3. The same 2y plus 3. They're putting it in place of x. The 40 is the same as this 40. The 16 is the same as this 16. They are just repeating. So if this equation where there was x here, if the solution of this equation is given like this, what's the solution? The solution is x minus 6 is equal to 0 when this is x. So what is x there? It means x is equal to what? Transpose to the other side, x will be a positive 6. Please listen to me. When x is equal to 6, this is the value which satisfies this equation when this is x here. But look now, where x is, which is the same x which is 6, where x is, this time it's no longer x. They are now putting this as 2y plus 3. So we are simply saying if they can write 2y plus 3 in place of x, it means 2y plus 3 is equal to x. They just substituted what is equal to x as an expression. Just like that. They just substituted something equivalent to x, but as an expression of y. And now we have got the numerical value from this equation that they told us that x minus 6 is what? It's a 0. And we saw that x is 6. So if x is 6, it means 2y plus 3 also must be equal to 6. So what is the value of y? That is what they are testing. They wanted you guys. They wanted you on this question. They wanted a lot. So be careful. Very, very careful. So 2y is equal to transpose. We are now solving for y, in this case, an equation. So you can now solve for y. Transpose 3 to the other hand, it becomes a negative. So that's 6 minus 3, which is a 3. How do we solve 2y? It's a multiplication, so you divide by 2. So therefore, y is equal to 3 over 2. So that's a single solution, one solution that we are having there, which is the value of y. So you see, how do they try to manipulate what you know just to confuse you guys? So don't tend to be confused whenever you see something like this. Solve for x and y simultaneously. So there we are given two simultaneous equations, y minus 1 is equal to 2x. So this is, let's say, our first equation. Then we are also given x squared plus xy minus 3x minus y plus a 2, which is equal to 0. This, let's say this is our second equation, and 5 marks to solve for x and y. All right, so that is what we have there, 1.3. How can we solve for x and y? That is the question. If we are to consider this, we know that it is the best way is to use our substitution method, where it's either I'm going to make x the subject, substitute in another equation, or I make y the subject, substitute in another equation. So there is your choice. Which part are you going to use from these two? So if you were to consider the first equation, it is easier for us to work with the first equation. In the first equation, we can just make y the subject, transpose the minus 1 on the other side. That's a positive one. That's a positive on the other end. So it's easier for us to make y the subject. So from equation, from equation 1, we're going to make y the subject. So y will be equal to 2x transpose 1 on the other hand, minus 1, it will be a positive 1. So this is another equation that we never had, but we have to formulate it from another equation. So we can name this now our equation 3. So this is the whole idea of your solving of this simultaneous equation. Just work with the easiest part. Just imagine you want to work with the x. You can divide by 2, divide by, just look, you're working with a fraction there. You are working with a fraction, and when you substitute, there's an x squared, meaning to say you have to square. So be careful, also analyze your equation. It's not just I have to make the subject. Analyze and see what's easier for you to work with. Not to say you're not going to have the same answers. You will have the same answers, but avoid working with complicated situations. So just analyze before you do that, then you can solve. All right, so from the equation 3 that we now have, you are going to substitute in the other equation, not the first one, no, because that is where you made y the subject. So you substitute into the other equation. So you are going to substitute equation 3. So now I'm just going to write in short. So I'm just going to write in short. Substitute equation 3 into equation 2. All right. So you're going to substitute this into equation 2. That's in equation 2. Wherever there is a y, you are going to substitute the equivalent of this, which is 2x plus 1. All right. So this is x squared. There's nothing to be substituted there. Then we've got plus xy. Where there is a y here, you substitute what is y. So xy means x times. You multiply to what is representing y, which is 2x plus 1. Minus 3x minus y, in this case, where there is a y, just open a bracket, substitute what represents y there, plus a 2, that's equal to 0. Always substitute properly. Okay, open brackets whenever it is very, very necessary. All right, whenever it is necessary, do that. And with this equation, we can see that we are just left with x. So we can solve for x. So expand the brackets, x squared, that's x and 2. This is going to be 2x squared, x and 1, that's plus x, minus 3x. Then here there's a minus 1. If the number is not indicated invisible, there's a 1. So it means minus 1 times 2, x minus 1 times a 1. So you're going to have minus 2x minus 1 and a positive 1, a minus 1 plus a 2, that's equal to 0. So what I want you to do is to solve, to combine the part of x squared. This is 1 and 2. So 1 plus 2, that is going to be 3x squared. You do the same thing on the x. This is 1x. So this is 1x minus 3x minus 2x. So this will be minus 4x. So you are going to obtain minus 4x there. Minus 1 plus a 2, that's a positive 1, which is equal to 0. So having this equation that you are seeing here, solve that equation. To solve, it is your way. Use your quadratic formula, factorization. So in this case, I hope we used the quadratic formula. We used the factorization before. So this one is our choice. I'm just going to use the formula. In this case, most of you guys, I see you have a confusion whenever you see a number like a 3. So if you have that confusion, just avoid that. Just avoid, use your formula minus b plus or minus the square root of b squared minus 4ac, substitute your values, you are done. So x will be equal to minus, remember, this is our ax squared, bx, and c. So our a is 3, our b is minus 4, and our c is plus 1. So you're going to have minus b. So b is a negative 4. That's why we're going to have minus there, plus or minus the square root of b squared, our b, which is minus 4 squared, minus 4 times a, which is 3, and our c, that's a positive 1. All right, everything here is over 2 times a, our a, which is a 3. So if you were to simplify this so that you avoid confusions, like I say, just simplify what is inside of the square root. But this one is not part of our question, so you can even avoid that. But just try to simplify this part under the square root. So let me just be a coach to show you what I'm trying to say here. This is what I'm trying to say. On this part, you are going to do it like this. So just simplify. This will be, open a bracket, just going to have minus 4 squared. So that's minus 4 squared, minus 4 times 3 times 1. So that's it. Times a 1. All right, why is this calculator now just stuck, guys? You see, these calculators now, these softwares, they just tend to misbehave sometimes. All right, that's a 4. So meaning to say we're going to have minus, that's a positive. So it's 4 plus or minus the square root of. So you simplify the whole part here, you got a 4. Everything over a 6. 2 times 3, that's a 6. All right, so meaning to say x is going to be what? Now you can do whatever that you want in this case on your simplification. All right, so they're going to have a fraction. Then you have 4 plus, you go back here, or you just use this one. It's up to you. The square root of 4 over a 6. So the first solution is giving us a positive 1, or x is equal to, we move on to the other solution, which is we're just going to put a negative, and this is going to be 1 over a 3. So we are obtaining two values of x which can be a 1, or x which can be 1 over 3. And with these values of x, you cannot substitute where in equation 3, because if you check, equation 3 is the best equation to substitute to find the y values, because already y is the subject. Y is equal to 2x plus 1. So taking that into consideration, and also as an advantage that y is equal to 2x plus 1, you're just going to substitute. When x is equal to 1, you substitute here. So y was going to be a positive 3. If you substitute, when x is 1 over 3 on this part, you substitute 1 over 3. You are going to see that your y value was going to be 5 over 3. So this, like a pair. You're simply saying when x is 1, y is 3. You can even write as points 1, 3 like this, and another point where x is 1 over 3. 5 over 3. This presentation is up to you. It's up to you. Writing this, that x is this value and y is this value at this point is enough. So writing as points, it's another part. It's up to you. Unless if the question was determine the coordinates of point of intersection, you have to indicate in point form when it is like that. You do not have a choice when it is like that. So like I said, you could have used factorization. So I want you to use the factorization and see if you are having the same answer on this part here. Use the factorization to prove if you are having the same answers on the values of x. If not, then that means there's something that you need to be worked on that part. 1.4, we are given, show that this equation that we are given, yes, two real and unequal roots. The first thing is they're supposed to be real roots, that is any real number. It can be any real number, meaning to say what we are talking about when it is a real number. We talking of the solutions, it means our discriminant or our delta part. Just for having real solutions, it must be greater than 0. So they are saying now, is this going to be the roots? They are real and unequal. They are not equal. Okay. So what is the case now? The discriminant, what does it mean? Or our delta, it is taken from the equation ax squared plus bx plus c. And we know that if we are given this nature, this discriminant, which is our delta, is supposed to be b squared minus 4ac. So we could b squared minus 4ac, but we need the format from this. We need first the format because it must be of this nature equal to 0. So this equation we are given as x squared minus px minus p squared is equal. It's not equal to 0. It's equal to what? To 2. This must be equal to 0. So what you're going to do is to transpose the 2 to the other side. X squared minus px minus p squared minus 2 is equal to 0. So it was a positive. It will be a negative. So this must be ax squared. Ax squared. So our a is a 1. Plus bx, bx, there must be x. So our bx, we're talking about b, this is our b. So this is our a, this is our b. C is the constant. On the constant, there is no x. So they can put any letter what they want, but if there is no x, this whole part is our constant. This is our C, where we do not have x. Where we do not have a variable, like the variable is x. P is a constant. Now we treat P as a constant, even though P is a letter. But we are treating it now, or we are taking it as a constant for now. So meaning to say, if I am to use the b squared minus 4ac, let's check our b is p minus p. So that's b squared minus 4ac. B, which is going to be minus p squared minus 4 times a, which is 1. Our c, that is minus p squared minus 2. This is our delta, which is our discriminant. So minus p squared, remember a negative from our grade 9, when raised to an even number, it becomes a positive. So that's p squared minus 4 times 1, that's minus 4. So it means we've got minus 4 into the bracket of minus p squared minus 2. So that's minus, that will be a positive. 4p squared minus, that will be a positive 8. 4 times 2, which is 8. So if we are to add, this is 1p squared, 1 is invisible. 1 plus 4, that will be 5p squared plus 8. So the question is, are the values of p that we are talking about here going to maintain that this is great? Because we said it must be greater than 0. It must be greater than 0. All right, this is it. I want you to think of any value of p, of your choice, any. The moment that you square a value, whether it was a negative, whether it was a positive, the moment that you square this, it becomes a positive at the end. Becomes a positive at the end. So 5 is positive, 8 is positive, p squared is positive. So there is no way this expression that we are having there is greater than 0. P squared, it is a number that is, it can be great, it can be p can be a 0. You square a 0, you get a 0. P can be a 1. P can be, so meaning to say, if you square that p, it can be equal to 0, because if p is equal to 0 and you square this, that will be a 0. If you have minus 1, you square minus 1, if you have a 1, you square, it's a positive. So meaning to say, whatever p you square, it is going to be something that is greater than or equal to 0. For any p that represents every real number that we talk about. So if it is like that, P squared is a positive, and you multiply, guys, a positive times a positive is what? It's a positive. So meaning to say, if I multiply 5 to P squared, what am I going to get? I'm going to also get a positive value greater than or equal to 0. What if I add a positive to guys, I add a positive to a positive value? The answer will be positive. So the moment I add this 5P squared plus 8, this one that I'm having here, this whole thing here is going to be what? Greater than also 5P squared plus 8. Now it won't be greater than or equal to 0 because you are now adding 8. So if it was a 0, 0 plus 8, it's no longer greater than or equal to, is just greater than 0 now. Take note, because you have added, if you are at 0, you add 8. Are you still at 0? No, you are no longer at 0. So it's no longer equal to 0, but it can be greater than 0. So as we can see, our discriminant at the end, it is something greater than 0. And if it is greater than 0 for any p value which represents a real number, therefore, what does it mean? It means that these roots are equal, and also these roots are real and unequal. So therefore, the roots are real. That is the first thing. They are real and unequal. All right. So you need to know the conditions that makes the roots to be what? To be real and unequal on your quadratic equations there when you are dealing with your quadratic equations. So the format first of a quadratic equation, we need the format. Before you talk of the b squared minus 4ac, the format is taken from the format. That is the idea there. All right. So on question 1.5, you are given a farmer constructs a rectangle enclosure using 100 millimeter of fencing. The fencing that is used, it is 100 meters. He uses one existing boundary wall as one side of the rectangular enclosure, meaning to say, as you are making, as he was making his rectangular farm, another part, it was to be covered by a wall. Another part yet to be covered by what? By a wall, not a fence. So the fence is this one. This is our fence. Remember, it must be a rectangle at the end. But as you are forming a rectangular field, one of this part is covered by a wall. But this is, so meaning to say, this is our fence. So this fence that we are seeing here, it is 100 meters long. So let's just say, because this is a rectangle, so you can consider the length and breadth concept. The opposite sides of a rectangle, we know they are equal. That's our length and breadth, or you can consider length and width. So let's say this is what we have. What it means is that if you add this part of this, because this is your fence, this one, this is the fence. How long is the fence? It is 100 meters. So meaning to say, if we add where the fence is from, it's from B to L to this other B, we must get the 100 meters, which is of the length. So meaning to say, we are going to have L plus B, that is 2B, is equal to 100. This is just an equation that you're obtaining from the fence, the way that you're given, and also from the properties of a rectangle. I don't know, maybe used X and Y, it's up to you. So it will be X plus Y plus X. So at the end, you have to form a same equation or a similar equation. All right. So this is not about our question. I'm just talking about what this statement means. So the question is, calculate the dimensions of the rectangle from this rectangle that we are seeing to obtain maximum enclosed area. Maximum area. So we are talking about the max to obtain. What are the dimensions to obtain the maximum area? So what you need are the dimensions there first. But these dimensions that gives the maximum area. So how do you answer this type of a question? Whenever you hear about maximum area, maximum surface area, minimum this, these are maximum and minimum values. Maximum and minimum values. If you are to consider this as you continue in your grade 12, we shall talk of the derivatives, where you can use derivatives to determine maximum and minimum values. So in our syllabus, how do you consider the maximum and minimum value? We know that from a quadratic function, if y is equal to f of x in the format of ax squared plus bx plus c, as long you have a quadratic equation and it is of this nature, at x is equal to minus b over 2a, that's y is, at this value, y is maximum or minimum. That's it. So at the maximum or at the minimum value, x must be equal to minus b over 2a, as long your equation is in this format. So they are talking about having an area as a maximum. Do we have the expression for area? No, we do not have. So let's find it. We know that the area of a rectangle, because the shape that we are given there is a rectangle, is determined in the term of length times breadth. So with this expression, there's nothing that we can do. We can't have minus b over 2a. We must have the same format of a quadratic and also having the same letter. If this is x, let it be x. So how can we have this? It's either we can write from this equation of the fence. Remember, the fence is 100 meters. So from that equation that we wrote, it's either we are going to make L the subject or you are going to make B the subject. So let me make L the subject. From here, it means L is equal to 100 minus 2B. It's easier for us to have L as the subject. So if L is equal to 100 minus 2B, let us substitute it back here. This is what it means. It means this area can be given or can be written as the area is length, where our length is 100 minus 2B times the breadth. We're not going to change the breadth because you want to write area in terms of the same variable. Is it B or is it L? So B is not going to change. We changed L to be a B. So B remains as it is. As you can see, these are now brackets. You can expand the brackets times B, that is 100B, times B here, this will be minus 2B squared. Having a closer look, we are seeing exactly the format of a quadratic equation in the form of ax squared plus bx plus c. So it means our area can be given as minus 2b squared, taking the highest power into consideration, followed by x, which is followed by what? By 100b, then followed by the constant. And in this case, the constant, if not given, it means that's a 0. So this is it. Exactly the format. So at this point, at this, for a maximum value, for a maximum, not to say x is our maximum, no. Y is the one that will be maximum or minimum. So we are saying for any maximum value, x at a condition was supposed to be minus b over 2a from this formality that we have. Our x. So we are no longer having it as our x in this case, because, so just to don't confuse guys, it's no longer x. This is now a b. So meaning to say at our maximum value, our b as of this equation, b at maximum value, for maximum value now, b is equal to what? B is equal to minus b over 2a of the, this one is of the formula when we are writing this in the form of ax squared plus bx plus c. So our b there is the coefficient of x, which is the coefficient of b, which is this one, 100. So it's going to be minus 100 over 2 times a. A is the one that affects what? B squared from x squared. A is the coefficient of what? Of x squared. And what affects our square is -2. So it's 2 into -2. So this will be the value of b at the maximum value. For a maximum value, this must be equal to minus b over 2a. And what represents that x is no longer x, it's now a b. So b is equal to minus 100 over 2 times minus 2 at the maximum value. So it means our b at the end was going to be 25 at the maximum value. So if b is 25 at the maximum value, what about the value of a? What about the value of the length? B is the breadth. What about the length? Remember, I said length is 100 minus 2b. So it means we can determine our length from there, because this is 100 minus 2 times the breadth. So that is 100 minus 2 times the breadth that we calculated, which is 25. So our length at the end was going to be 100 minus 50, which is going to be 50. So that is it. These are the dimensions that will give us the maximum area. So if we take a closer look, the other units that we're given, the units of the fence, it's meters. So it means this b, this length, breadth are also in meters. So our breadth is going to be 25. Our length is going to be 50 meters. For this value, our area must be maximum. Or you can use completing of the square method, which is another way out to your simplification. If you want to use that, you can also work with your completing of the square method. So that was the first part of our question, which is question number 1. We're going to consider what follows next on this question paper, June 2023, paper 2. All right, that's a nice question paper actually that we are having in hand at this time. So what is it that we are given? Simplify without the use of a calculator, meaning to say a calculator is not needed in this simplification. You are not supposed to have a calculator. Yes, you can just use for your verifications, which is fine. 2.11, we are given, that is, let us just have it here, 3 to the exponent of n plus 2 multiplied to 9 to the exponent of n plus 1. This here is over 27 to the exponent of n minus 1. That's 3 marks. So if you have to consider, you were seeing that I said when we are dealing with our exponents, remember? The best way to work an exponent is to work it as the simplest number. And the simplest number, we are simply talking of prime numbers. We are simply talking of prime numbers. These are the simplest numbers that you think of when working with your exponents. If your numbers are in simplest form, everything will work smoothly. Okay, what am I trying to say? Prime numbers, we are talking about numbers such as 2. Okay, when you divide by, it's just divisible by 1 and itself. Divisible, exactly divisible by 1 and itself. So examples, we've got 2, we've got 3, all right, we've got 5, we've got 7. All these are prime numbers. So you are going to think of these numbers to say, all right, I'm given this expression. So 3 is already a prime number. It's already in simplest form. Remember, I want to write these numbers in its simplest form. So already 3 is in simplest form. I'm just going to rewrite as it is. Times, is 9 a prime number? No. So how can I rewrite the 9? Okay, to be a prime number, but it must remain as a 9 as it is. We think of a 3. 3 to the exponent of 2 gives us a 9. So meaning to say, in place of 9, we've got 3 to the exponent of 2 multiplied to n plus 1. 27, again, is not a prime number. There are so many factors there, but it can be written again in the base of 3 as 3 to the exponent of 3 into n minus 1. So you can also use your calculator to check if you are not sure about your numbers. Just try your numbers, 3 to the exponent of 1, 3 to the exponent of 2, and so on. This is how you just try your numbers. You just have to make sure you work with each part that you are given until you get that number. At least you have an idea that I am in the base of 3. So you can try 3 to the exponent of 2, that's a 9. So I know that, okay, to have a 9 is 3 to the exponent of 2, 3 to the exponent of a 3. You can use your calculator. No one is going to actually understand what you're doing there. All right, this is it. We know that an exponent and exponent can be simplified together. Exponent to exponent. If I am given, this is x, maybe whatever that I'm given, raised to a certain exponent, and also there is another exponent, you can simply multiply the exponents together in that situation. So meaning to say 3 to the exponent of n plus 1, there's nothing, also just leave it like that. 3 to the exponent, there is an exponent and exponent, so multiply by 2, distribute by 2 times 2, that will be 2n times 2 here, that will be a positive 2. Okay, the same thing, 3 distribute in this bracket, so it's the exponent of 3n, 3 times minus 1, which is a minus 3. So now that we have got the bases which are the same, if we check on the numerator, you can consider to say that this is the base of 3, this is the base of 3, but what is happening? You are multiplying the bases that are the same. So if x is being raised to the exponent of m and being raised to the exponent of n being multiplied, we add the exponents. So meaning to say this was going to give us 3 to the exponent of n plus 1, we add. So when you are adding, don't worry about the brackets, all right? It does not affect anything. So you can just write plus 2n plus a 2. But in actual sense, you were supposed to have a bracket there. But like I said, addition does not affect anything. Checking again, in the denominator, there is also a 3 in the base. And this time we are dividing, all right? We are dividing everything that happened. There is a division. So what is going to happen if you are dividing x to the exponent of m, this time being divided to x to the exponent of n, you are going to subtract the exponents. So meaning you are going to subtract, and for a subtraction, always open the bracket because the negative, it affects everything. So for you not to have a confusion to say, where am I going to open a bracket or where am I not going to open a bracket? Just whenever you are working with an algebraic expression, open a bracket in simplification so that you won't make any mistakes. So this is where we are. We could have simplified the numerator on its own. We get our answer, then we move on to the denominator. It's another way you could have done that, but you can also simplify at once. So maintaining the same base of 3, this will be, okay, let's just expand here. So this will be n plus 1. That's a plus 1 times 2n, as you can see, that would just remain as it is. Plus 1 and plus 2, that's a plus 2. But if you check on the negative, this is a negative 1. So if you distribute this by negative 1 times 3n, that's minus 3n. As you can see, the negative changes. Negative, negative, that's a positive 3. So we are going to collect the terms together of n. This is 1n, all right, plus 2n. You move on, there's a plus 2n minus 3n. So 1 plus 2, that's a 3. 3 minus 3, that's a 0 there. So you're going to remain with a 0. You move on to the numbers. This is 1 plus 2, which is 3. 3 plus 3, which is a 6. So that's 3 to the exponent of a 6. All right, guys, this is what we are going to have at the end. All right, there was a 2 there. There was a 2. All right, this is 1 plus 2, which is a 3. Okay, then 3 plus a 3, that is going to be a 6. All right, guys, in my preparation, you see I got something else. So I just want to check here what actually transpired. This transpired here. It transpired here on this one. This is supposed to be a positive 2 there, a 2 there. We are still having a 2. Just correct this, guys. So that's a 2 here. That's a 2 here. All right, so my preparation actually tells me something. That's a 2 here. All right, so 2 plus 2 plus a 3, that was going to be a 7, not a 6. So let's correct this one. That's a 7. All right. So since the calculator is not needed, don't waste your time trying to multiply 3. There's so many numbers. Just leave it like that. All right. Just leave it as it is. You are done. So this is how you're supposed to do. So these are some of the errors that you are supposed to get rid in exam. Try to simplify properly your calculations. You'll see that you won't even go wrong. All right. 2.124 marks. It is given that x squared plus 1 over x, simplify this if x is equal to this. All right, let's see what we are given there. This is a 2.12. We are given a certain expression, x squared over 1 plus x. So we are supposed to simplify this given that x is equal to 1 plus the square root of 3. So these are just simply sets. We are back to those sets that we talked about before. That this whole expression that we are given of x squared plus 1 over x is equal to, in place of x, we are going to substitute what represents x, which is 1 plus the square root of 3 squared. And this is over 1 plus x. Our x is given as 1 plus the square root of 3. So like I said, if you're ever dealing with an expression 1 plus, just open a bracket, but looking at the plus does not affect anything. So you can even ignore that. So these are sets. As we have got laws that govern these sets, we are supposed to make sure we maintain those laws. A square simply means you are expanding the two brackets, or you can use the concept of a plus b squared, which is equal to a squared plus 2ab. Remember your identity from grade 10 plus b squared. What does it mean is that we've got a squared, a and b, that's first and last term, first, last term. So this is your first term. So it's going to be first squared, which is 1 squared and 1 squared. That is simply a 1. Plus 2ab, that is 2 times our a, which is the first term, which is 1, b, which is the second, or the last term, which is the square root of 3. So 2 times 1 times the square root of 3 was going to give us 2 square root of 3. Then we move on to the last part, which represents b squared. B is the square root of 3, and we've got the square root of 3 squared, that is b squared. If you do not know this, you can just use your calculator. No one is going to know that you've used a calculator there. The square root of 3 squared is equal to 3. The square root of 3 times the square root of 3, that is from the law, square root of a times the square root of a, we obtain a. Or you can multiply the numbers. 3 times 3, that is 9, and the square root of 9 is a 3. Or this law states that if you're multiplying the numbers that are the same, as long as you're multiplying the numbers that are the same, the numbers are the same under the square root, right? You obtain that number under the square root. So meaning to say the b squared, which is the square root of 3 squared, was going to give us a 3 at the end. Or just expand your brackets if you do not understand this part of the a plus b squared. These are your brackets. 1 plus the square root of 3 into the bracket of 1 plus the square root of 3. 1 times 1, that is going to be 1, plus 1 times the square root of 3, which is the square root of 3. The square root of 3 times 1, that is the square root of 3. The square root of 3 times the square root of 3, which is our 3. Or the square root of 9, which will give us a 3. You simplify this, there's a same as there's a 1 and there's a 1. So 1 plus 1 is going to be 2. Square root of 3, 1 plus 1, that will be a 4. So that's it. You can also expand your brackets. In this case, you can use this concept, but at the end, we can see that these numbers can be simplified together. The 1 and the 3, we're going to simplify that. Do not worry. All right. So everything over here, we can simplify 1 plus 1, that is a 2. So we've got 2 plus the square root of 3. So let's add our numbers. 1 plus 3, that is going to give us 4, plus 2 square root of 3, everything over 2, plus the square root of 3. So sets, they use rules or laws in their simplification, and you are supposed to understand those. So if you are to give, if you are given this condition, that is the idea there. If you are given a situation that you have got a division of sets, a division like this. And you have got two terms that are adding like this. You are supposed to do what is called the rationalizing of the denominator to make sure that the denominator remains with a rational number, a whole number, not a square, not a set. This one is a set. So how do you do that? You multiply, you introduce a negative in the denominator where there is a set. So this will be 2 minus the square root of 3. You do this also in the denominator. So you multiply both the numerator and the denominator by introducing a negative, this one. In the denominator, you introduce a negative. By doing that, you are going to see that you have a rational number. So that part actually, you're gonna talked about that on our sets. So make sure that you watch those videos also on the sets. So in the numerator, you're simply going to multiply. These are just two brackets to be multiplied, the same thing. And the denominator also. So if you do not want to have confusion, you can just rewrite this as 4 plus 2, the square root of 3 in a bracket, into this 2 minus the square root of 3, this other bracket, 2 plus the square root of 3 in one bracket, another bracket, there's 2 minus square root of 3. Do not cancel this, because if you cancel, you are neutralizing your question. You are now back to the original question that you had. So never be tempted to do that. Just expand your brackets. 4 multiplies the 2, that is going to be 8. 4 multiplies the square root of 3, that is going to be minus 4 square root of 3. All right, you are done with 4. You move on to the plus 2 square root of 3. It multiplies 2. So that's, you distribute here. 2 times 2. That is going to be 4 square root of 3. 2 square root of 3 multiplies minus square root of 3. So it's like this. 2 square root of 3 times a negative square root of 3, like this. So remember what we got previously. Square root of 3 times square root of 3. It gives us a 3. So it will be a minus 3, and 2 times minus 3 is going to be a minus 6. Remember, guys, we talked about this before when we got this 3. It was from square root of 3 times square root of 3. So I'm not going to talk about that again. Consider the previous case. All right, with the same idea, you are going to expand the second bracket. 2 multiplies the second bracket. Everything in the second bracket must be multiplied by these 2. So that means 2 times 2 is going to be 4. All right, then we've got 2 and minus square root of 3. So there's a minus 1. So 2 times minus 1 is going to be minus 2 square root of 3. You are done with 2. You move on to 1 square root of 3. It multiplies 2. So it's 1 times 2, which is going to be 2 square root of 3. All right, we do the same thing on the square root of 3. This is square root of 3 times minus square root of 3. So there is a minus square root of 3 there. So the square root of 3, the square root of 3, we got a 3, remember, but this time there is a negative. So it'll be a minus 3 at the end. Remember your simplification of the square root of a 3. All right, with this situation, you are going to see that there is something that is happening that you need to consider here. These are like terms, all right? The same thing with the whole numbers also are like terms. So meaning to say I can simplify this 8 minus 6. So 8 minus 6, if you simplify this, that is going to be a 2. Minus 4 square root of 3 plus 4 square root of 3. These are the same. So minus 4 plus a 4, that's a 0. So 0 square root of 3 is same as a 0. So there's nothing that you're going to have in that part. It's just going to be a 2. Over, you do the same thing. 4 minus 3, these are all numbers. So 4 minus 3, that is a 1. Minus 2 square root of 3 plus 2 square root of 3 minus 2 plus 2, that's a 0. So I talked about this. So 0 square root of 3, that's a 0. So meaning to say you're going to have 2 over 1, which is a 2. That's it. So as you can see, the square root on the square root there, they eliminated each other. So that means you're not going to have them in your simplification. That is how our questions might be given as. So this is what it was going to be at the end. All right, let us consider 2.13. Again, simplify, and this is 4 marks again, and A is not equal to B on this expression. So we are given this part. I'm just going to rewrite this. All right, let me just rewrite here. So that's 2.13. We are given to simplify the square root of a squared minus b squared like this, multiplied to a plus b to the exponent of 5 over 2. All right. And this whole part here is divided to, all right, sorry guys. This is divided to a minus b to the exponent of 1 over 2 like this. If you were to consider this as maybe square root of x times maybe x to the exponent of 5 over 2 over maybe x, you had something that is about the same basis that you understand much because it is written as x. You understand that much. Guys, as long you see these exponents there, think of the exponents also, the laws of your exponents. In the same manner that you understand that if you are multiplying the bases which are the same, you add your exponents. If you are dividing these bases which are the same, you subtract your exponents. In the same manner, a minus b, if it is the same, that is the same base. A plus b, if it is the same, that is the same base. So the question is, can we have another a plus b or maybe another a minus b so that we can simplify this? From where? Okay, let's consider first. The square root is the same as to the exponent of a half. So this is just given or can be written as to the exponent of a half. Remember from your laws of your exponents. A plus b to the exponent of 5 over 2, there's nothing that you can do. Never be tempted to expand that one. You can't expand this one in your syllabus unless you go to another higher level. But for now, in your syllabus, that one is impossible. You can't expand this type of a fraction. Just leave it like that. But if you are to check, we understand that a squared minus b squared, this is a difference of 2 squares, which is going to give us 2 brackets. In actual sense, we are supposed to have the bracket of a minus b into the bracket of a plus b. Being affected to the exponent of 1 over 2, everything that we are seeing here being affected to the exponent of 1 over 2. Our difference of 2 squares, which is the a squared minus b squared. But there is an exponent of a half there. So what does it mean? It means everything in this bracket is going to be raised to the exponent of what? Of 1 over 2. The bracket of a minus b will be raised to the exponent of 1 over 2. The bracket of a plus b will also be raised to the exponent of 1 over 2. We have expanded this part. All right. With this, we move on to the other part. We are still multiplying this. There is a bracket there, a plus b to the exponent of 5 over 2. In the denominator, there is a bracket of a minus b to the exponent of 1 over 2, which I said we can't simplify this. But by having now these same brackets, the brackets that are the same, the bracket of a minus b and also the bracket of a minus b, this alone tells us that there is something that we can consider. And besides that, these 2 brackets are exactly the same, even without applying our laws of exponents. Without this, these 2 brackets are exactly the same. So I can just cancel these 2 brackets. That is x over x is a 1. X over x is a 1. So if you are given that part, if you are given this part, you can cancel, you can even cancel. So meaning to say that if you are given a consideration where the same, you can cancel. But let's say you did not recognize that, you just recognize these are the same bases, then you want to subtract your exponents. You are going to subtract half minus half. It's going to be a minus b to the exponent of a 0, and this will be a 1. The whole bracket is being raised to the exponent of a 0 there. So still, you are going to get a 1. All right. Let's move on to the other part. We have got another part which is the same in this case, the bracket of a plus b and the bracket of a plus b. These 2 brackets are also the same. In the same manner, but this time we are multiplying. So on the multiplication, we said if the bases are the same, what do? We add the exponents. So in this case, if you were to add the exponents, it was going to be a plus b. You add, this was going to be 1 over 2 plus 5 over 2. Remember, if we've got this consideration of the same denominators, just add your numerators, 1 plus 5, which is 6 over 2, sorry, 6 over 2, and this is going to be a 3. So that was going to give us a plus b to the exponent of 3, which we can expand. But remember, this is also an identity that you're supposed to know. A plus b to the exponent of 3 is same as a cubed plus 3a squared b plus 3ab squared plus b to the exponent of 3. 3a squared b plus 3ab squared. So take note, a squared b, then it's going to be ab squared. Then a and b are the bodyguards being raised to the exponent of what? Of 3. So it's an identity that you are supposed to also understand, or that you are supposed to know. All right. So each and every part that you have, you are supposed to understand your identities. You can simplify your identities, know your identities. You're going to expand one, guys, it's up to you. So this is it. Just like that. So you see, the laws, everything has to be applied properly. Prove that this whole part that we see is equal to minus 2, 4 marks. We are supposed to prove this. That's 2.2. All right, we are given 2 over 1 plus the square root of 2 minus 8 over the square root of 8. They are saying this whole part must give us a negative 2. To prove it means you are supposed to take one of the sides. So guys, it's going to be complicated to start here it's going to be very complicated. So it's easier to work from the complicated side to the easier path. All right. So choosing the left hand side, we are going to see that we have got 2 over 1 plus the square root of 2 minus 8 over the square root of 8. This is what we have. I talked about rationalizing of the denominator previously, if you still remember how we calculated this part. It is the same thing as long we have got this denominator having an irrational term, an irrational number, a number under the square root. But I said if it is an expression like this, you introduce a negative where there is a z, where there is a square root. So this was going to give us, let us just consider it like this. So this was going to give us 2 over 1 plus the square root of 2. So considering the part where the z is, if we introduce a negative, this was going to be plus, you multiply a plus and a minus, so it will be minus the square root of 2 over 1 minus the square root of 2. Multiplying by the numerator and denominator, which are the same, simply means you multiplied by 1. So there is no effect on that one. There is no effect at all. There is no effect. This happens when you introduce a negative. It is when you are given two terms, you are adding or subtracting. But when you are given a single term, like this one, a single z, there's nothing added, there's nothing subtracted. You multiply by that z as it is. So it's minus 8 over the square root of 8. So the square root, it's an irrational number. So you want to rationalize this, you multiply by that z as it is. It's a single term. There's nothing added. It's like there's a plus 0 there. So what were you going to do? It was going to be, guys, there's nothing. All right. So when you're given a single z, just like a 0, there's plus 0. So just use that single z as it is to rationalize. Why? Remember, I say the square root of a number times the square root of that same number. If this is a and this is a, the answer will be a. So if you multiply the square root of 8 to the square root of 8, 8 and 8 are the same. So the answer is going to be 8. Or you can multiply 8 times 8 to square root of 64, which is 8 again. one and the same. So by rationalizing, we can simplify. The numerator multiplies the numerator on its own. So guys, as you can see, 2 is going to multiply everything here. 2 times 1, that is going to be 2. 2 times minus square root of 2, that will be minus 2 square root of 2. There is a 1 there, minus 1. Everything over the denominator, you do the same thing. 1 is going to multiply with 1. That is going to be 1. You move on to this 1 multiplies minus square root of 2. That will be minus the square root of 2. So you've got minus the square root of 2. You are done. You move on to the square root of 2. It's a plus here. So square root of 2 times 1. That is plus square root of 2. You move on. The square root of 2 times minus square root of 2. Remember what I said? Square root of a number times the square root of that number is that number. So the square root of 2, if it multiplies the square root of 2, we are supposed to get a 2. But because plus and minus on the multiplication, plus and minus on the multiplication is what? It's a minus. So it will be minus 2. Guys, on the multiplication, even on your calculator, no, just use your calculator. Just use it. It's the same. Because the answer that you're just getting there is the same as the one that will just knows this one by head. So if you're having confusion, just use your calculator to multiply square root of 2 times square root of 2, all right? No one is gonna talk about that. Minus, we do the same thing on our multiplication. 8 times the square root of 8 means we've got 8 square root of 8 over the square root of 8 times the square root of 8. We are back to that. So remember that we're going to get an 8 there. Then we simplify further. 2 minus 2 square root of 2. There's nothing that we can do. Everything over the denominator. There is a 1. There's a minus 2. These are whole numbers. So we can subtract 1 minus 2. That is going to be minus 1. Minus square root of 2 plus square root of 2, this is the same as minus 1 plus 1. Minus 1 plus 1, that's a 0 there. So meaning say there's nothing there. So this will be minus 8 and 8 cancels. We remain with the square root of 8. So at this stage, we are going to simplify, dividing by -1. Remember, from our grade 10, A plus B over C is the same as A over C. Over C, like this. It's same as A over C plus B over C. So meaning to say this is same as 2 over minus 1, which is going to give us what? Minus 2. The same thing, this one, minus 2 square root of 2 over minus 1. So if you divide minus 2 and minus 1, minus 2 and minus 1, that's a positive 2 square root of 2. All right? Minus the square root of 8 is not in simplest form. The square root of 8 is not in simplest form, this one. So it must be a simplest set. So it's either you're going to simplify that part, the square root is a prime numbers, 2 into 8, which is 4, 2 and 2. Then you've got 2 and 2, that's a pair. So a pair, you write it outside of the square root. Where there's no pair, you write it inside of the square root. It's up to you. But at this stage, I want you to be clear, because even someone who knows or understands that square root of 8 is same as 4 times 2 for a perfect square. And the square root of 4 is 2. Square root of 4 is 2. So the square root of 2, we do not know. So we still have the same answer. Even if you don't show this and use your calculator at this stage, do that. Do that. Do that. All right. So this is 2 square root of 2 minus 2 square root of 2. That's a 0 there. This cancels 2 minus 2. That's a 0. So at the end, you are going to obtain minus 2. So this is exactly what we are seeing on the right-hand side. So this is exactly what is equal to the right-hand side of our equation. So we take it as an equation. We take it as an equation. All right. We hope we take that one as an equation. You prove that this is equal to the right-hand side. Just like that. So they are saying, let's hope it's not a continuation. All right, this one is on its own. Okay, so all right, 2 plus this. All right, this one is on its own. I just thought maybe it's gonna be a continue, because most times they want you to continue from that. But anyways, this is on its own. 2.3, given that the triangle that we have in this case is an isosceles triangle JKL. If this is an isosceles triangle and we see a line drawn like this, perpendicular to the base, that line, it is not just perpendicular. It is the perpendicular bisector of this base. It is the perpendicular bisector, and it shows us that the sides of the isosceles triangle which are equal are these two sides. And this is the perpendicular bisector, which bisects this line into two equal parts. So it means from L to M, it is the same as from M to K. So if we are given the whole of LK as 4 units, we divide this by 2 because they're same. So it means we've got 2 units here. That is what it means. I'm just interpreting our diagram. If this is 2 plus square root of 3, it also means this is 2 plus the square root of 3, because these sides are the same. These two angles will be also equal. We are not there now into geometry, this and that, our analytical geometry. We are not into that now. All right. The question was, calculate the area of this triangle correct to 1 decimal place. Now you are given an instruction. That's why they told us before that you are supposed to determine whatever that you have to 2 decimal places unless stated otherwise. That's a condition of an otherwise, this one. They stated otherwise here. But anyways, even though they stated otherwise, we need to determine the area of this triangle. So how can we determine the area of this right-angled triangle? If you were to consider this is 2.3, the area of a right-angled triangle is given as half times the base times the perpendicular height. Which is the perpendicular height? We are referring to this JM. And the base of this triangle is going to be L to K. When you're given this triangle, this is the perpendicular height, this is the base. So meaning to say, in the calculation of this area, we were going to have something like this. Area is equal to half of the base, which is the LK, times the perpendicular height, which is from J to M. So you are going to be stuck in this JM. We have the L to K, which is this one. All right, so there was no need for us to even try this as 2 and 2, unless you want to use this triangle on its own, this triangle on its own, on the calculation. We're going to see that one where it is special, not now. LK, we have it as it is. From L to K is 4 units. What about JM? We do not have. From point J to M, we do not have. So this, we are stuck. We are stuck. So what are we going to do? We are going to use the piece of this triangle because it's a right angle triangle. So we can use just the piece of this triangle to solve for the third side. To solve for the third side means to find that third side. This is our J, this is our M, and this is our K. From M to K, we say this is equal from L to M, which is going to be 2 units. And we are given 2 plus the square root of 3, in this case as the hypotenuse, the one that is opposite or the one that faces the 90 degrees, the one that faces the 90 degrees. So we are supposed to solve for the third side, which is to calculate JM. How? Using our Pythagoras theorem, we understand that c squared is equal to a squared plus b squared, where c squared is the hypotenuse. So 2 plus the square root of 3 squared is equal to a squared plus b squared, which is a and b are the shorter sides that you're given. So you can write jm squared plus b squared, which is this side, the other shorter sides. By just given that this area is supposed to be given to 1 decimal place, it is a clear indication that we can also work with decimals in our simplification. So if I am stuck in my simplification on this one, I can just use my calculator. or I can expand. This is up to you. All right, so if I am to use the calculator, because most of us, we are used to this calculator concept. So let me just have this one so that we see how we're going to have on our simplification. So you are supposed to be very, very careful in this situation. You can just use your decimals because already you're told your answer should be 2 decimal places. So you can also use that 2 plus the square root of 3 in a bracket. Then we square this. All right. So this is 7 plus 4. You can even write it like that. All right. 7 plus 4 square root of 3, which is equal to what? 2 squared. So 2 squared, that's a 4. So it's going to be jm squared plus a 4. So transposing this 4 to this side, that is going to be a negative. So meaning to say we're going to have 7 plus 4 square root of 3 minus a 4 if we take it this side, which is equal to jm squared. So on this one, you subtract the numbers, this one minus this one, which is going to be a 3. 7 minus 4, that's 3, plus 4 square root of 3, which is equal to jm squared. How do I remove the square? I have to introduce the square root to determine jm. So jm is the square root of this. So you can even leave it like that as the square root of 3 plus 4 square root of 3. We're just going to leave it like that. There's no effect at all. There's no effect. Yes, you can use your calculator to have a decimal or just ignore. Right? Just ignore like that. It's fine. So this is our jm. Just substitute here. Having this, it means we are going to also have a better answer because our answer is going to be exact value because we never rounded off. So our answer is going to be the exact answer. So this is half of the base, which is L to K, which is the one that we have on our information. From L to K, that is 2 plus 2, which is 4 units. So we are going to have 4 units times jm. We calculated our jm from this, and we saw that is going to be the square root of 3 plus 4 the square root of 3. So it's just a square root under a square root. But do not worry about that because the calculator is there as your assistance in this exam. And also you are told to leave your answer to 2 decimal places. So that's an advantage. So meaning to say we are going to have 1 over 2 multiplied to 4 multiplied to the square root of 3. Inside of the same square root, there's plus 4 the square root of a 3. So this was going to give us 6.301, which is 6.3. If you do not know how to round off, just shift. You go to the setup. Remember, you fix your calculator to 1 decimal place since you're told to 1 decimal place. So this will be 6.3. So our area was going to be 6.3 square units or units squared. So that is how we could have calculated our area. Given this situation, you needed the idea of a right-angled triangle concept. Using the idea of a right-angled triangle concept, you can use that to calculate the the perpendicular height. Without the perpendicular height, it was going to be difficult for us to determine this area. But with your perpendicular height, everything is easy. Let's see what we have on the other. These are your typical questions. Your exam is going to be like that. So this was actually 21 marks on question on the wall of our question 2. 21 marks. This is a lot in exam. You need to know your simple questions, those grade 10 questions, revise as much as you can, go to your basics, know your basics. Question number 3, number patterns. We are given a sequence in that case. The first 3 terms of a linear sequence are These are the three terms that we have, and we are asked to determine the numerical value of x, 2 marks for that. Given these terms that we are given, and we are told that it's a linear pattern given x, given 4x plus 5, and also given 10x minus 5. And this is a linear sequence where we know that in a linear sequence, there's something that is very, very common, which is the difference. You work with the common difference. We know that this common difference is the same, t2 minus t1, second term minus the first term, third term minus the second term. It is the same throughout. So if it is the same throughout, let me find this and equate it to this. So you can formulate it as an equation. T2 minus T1 is, so your T2 is what? 4x plus 5, which is subtracting T1. T1 is just a term, just a single term, is x. So guys, there's no need for a bracket there. But if you want, just do that. This is equal to T3 minus T2. What is our T3? Our T3 is 10x minus 5, and it is subtracting T2. And our T2 is what? 4x plus a 5. Take note, know your formulas. All right, so let's subtract. This is just 1x there. So 4 minus 1, that is going to be 3x plus 5 is equal to 10x minus 5. Expand your brackets by -1. That is -1 times 4x, -4x times this, that's a -5. So if you were to collect your terms, this was going to be 3x plus 5 is equal to 10 minus 4, which is 6x, minus 5, that's a -10. So collecting the terms of x to one side of the equation is up to you which side you want to work with. You can move these terms, 3 to the other side, then 10 to this side. It means we are going to remain with a positive 5 plus a 10. It was a negative, so it's going to be a positive. 6x is already on the right-hand side. So if you transpose the 3x, it carries a negative. It was a positive. So on the other hand, it'll be a negative. 5 plus 10, that is 15, is equal to 3x. It's a multiplication, so just divide by 3 by 3. So meaning to say, if we divide by 3, that's a 1 on this case. So x is what? 15 divided by 3, which is a 5. So in this situation, you are going to have your x as a 5, which is the numerical value. The numerical value, they want to know what is your x, the number that corresponds. Before, these are expressions that we have. All right, so that is the value of x. Just so for x. All right, 3.2, consider the linear sequence. It's another question on its own. This one, consider this sequence, not another sequence, but this one that we are given as 11. It's a linear sequence, take note. All right, so that's our 3.3. We are given 17, 14, 11, and so on and so on. They are saying there are so many values there. Not to say there are 3 values. No, there are so many and so on. All right, up to the last one. So this is an indication we are going to continue with this up to a value when we have got -1. So remember, it was going to be up to -106. That was going to be the case. So the question is, determine the nth term if the nth term is given as, determine n if the nth term is given as. So we are already given. Remember, this is a linear pattern. You're going to use the common difference in this and that. You determine your expression Tn from the formula. Remember, your Tn can be written as A plus n minus 1 times D, or you can use that written concept. Your Tn is going to be the difference times n plus a certain value, where this one represents what? The common difference. And to find this, you use any given point. At the end, you're going to have this. So they already calculated that for you. They already calculated this for you. So you are not going to recalculate. No. It's a continuation, determine n. Why are they saying so? Because this time we are given a special term, which is the last term. In most cases, they don't even give you this last term, but there they gave you. Why? It represents that Tn is equal to the last term in the presentation. So if Tn is equal to the last term, it means minus 3n plus 20 is equal to minus 106. Tn is equal to the last term. So therefore, this is equal to this. If it is like that, minus 3n is equal to, we transpose this to the other hand, it becomes a negative what? A negative 20. It was a positive there. Minus 106 minus 20, it's minus 126. So dividing by negative 3, it means our n at the end was going to be a 42. So this is our n. That is what we're given there. We have the last, so you use the last term. All right. 3.22, which term is the first negative term in the sequence? Which term is the first negative term? So this one, it's up to you. Maybe you have got patience. If you have patience in your calculations, this is what you're going to do. I'm going to show you two ways. So this is 3.2. Sorry for that. This was 3.21. 3.21. Then we move on to 3.22. So 3.22, they are saying that we need something 3.22. We need the first negative value. Not the first negative value actually, but like on which term are we going to have that first negative? On which, what is the n? Which term is the first negative term in the sequence? Which term? Not the first negative, but which term, like if you're counting 1, 2, 3, 4, and so on. So if you have got patience, you're going to write these numbers, because if we check here, this is 17. There is a difference throughout here. There's a common difference. Remember, how do you calculate your D? T2 minus T1, which is 14 minus 17. That is going to be a negative 3. So meaning to say, each part, to get the next term, you were adding the difference of minus 3. On this one, you add minus 3. On this one, you add minus 3. On this one, you add minus 3. So on 11, if we add minus 3, what are we going to have? Okay, let's go back to our calculator. Let's get back to our calculator here. So this is it. Remember our calculator before we fixed this. So let's just go back to the normal mode. So we need the normal mode 8, then press 2. So this is what I'm trying to say. You had these, you are adding a minus 3 there. So it's 11 now plus a minus 3. This is what we have. You add a minus 3. This will be 8. Meaning to say the term that is following here is 8. You add again a minus 3 on that 8. So you add a minus 3 on this number until you get the next one. Until you get what? A negative. That's a 5. You add a minus 3. That's a 2. You add a minus 3. We are still on positive values. So if we add a minus 3, I want you to see here, we get, if we add, okay, why is it delaying now? That's a negative 1. We get a negative 1, and that's a negative, this one. We are getting what? A negative. That's our first negative number, this one. The first negative number is going to be minus 1. But the question is not asking us about the first negative number, no. Which term is the first negative term? Which term will correspond? So we count now. 1, 2, 3, 4, 5, 6, 7. So it is the 7th term. So n is equal to 7. We are talking about what? The 7th term. The 7th term. What is, or what could be another way if I do not, maybe there are so many numbers and now I have to consider, just imagine if you're adding, maybe there are so many values. It was going to be too much. So this is it. They are saying we need a condition when the first term is a negative. So it means that term, remember Tn is the one that represents the term. And the term is negative. So it means Tn is supposed to be equal to a negative value. So any negative value means values that are less than 0. We do not know that value. Is it going to be -1? So we can't say it is equal to minus this. But we know to be negative means the value must be negative. To be negative means it must be less than 0, I mean. To be less than 0 means a value is negative. So if Tn is less than a 0, and we have that Tn, we are given an expression for Tn, remember? -3n plus 20. So we take that now in terms of n. -3n plus 20 is supposed to be less than a 0. We solve. -3n is less than, remember, this is a linear inequality. So just transpose this, it becomes a -20. On the other hand, how do you find n? You divide by a -3. The moment that you divide by a negative under inequalities, you are going to reverse, to change the inequality. So it means n is now greater than 20/3. And 20/3 as a decimal is 6,666, something like that. So it means our n to have or to give us Tn as a negative number, n must be greater than 6,66 and so on. So which whole number, because n is numbers, like which number are we talking about? And it's a whole number. So which whole number do we have just after 6,66 and so on? The whole number that follows is 7. So n must be equal to 7. So you could have solved this from where? From this inequality concept. There are so many ways to consider. So many ways to consider. All right. Determine the value of the 20th odd term in the sequence. The 20th, guys, let's be mathematical when answering questions. Determine the value of the 20th, not just a term. No. If they wanted a term, they were going to write, but they even wrote this in upper caps, I mean, to show you that it's no longer what you have. This one is for odd terms, odd terms. So the question is, what is an odd number? So this here, it was Tn, not for odd numbers, but for everything there. Prime numbers, odd numbers, everything is there. But now it must be of odd numbers. These are numbers when you divide by 2, you're going to have a remainder, always a remainder of 1. You divide by 2, you have a remainder of 1. These are your odd numbers. So what are we talking about there? On odd numbers, when you divide by 2, you have a remainder of 1. Let's talk of 1, 3, 5, 7, and so on. These are odd numbers. Yes, some prime numbers are odd numbers. Some prime numbers are odd numbers. But as we are focusing on odd numbers, so it means we were supposed to create a sequence of odd numbers. This sequence that we are having, 11, 14, that we were given before, it was 11, 14, 17, 14, 11, 8. Okay, remember when we added those numbers, when I added those numbers, we got 8. And when we added -3, we ended up having 5. Remember when I was adding those numbers and so on. And so this is the sequence, that the original sequence. On this sequence that you have, you plug out odd numbers in that manner or order that you're given. You plug out the odd numbers to form a sequence of odd numbers. Because it must be of odd terms, odd numbers. So we must have a sequence of what? Odd numbers only. Only. If they wanted to talk about even numbers, you form that one for even numbers only. So, which odd numbers? It's now a new sequence. 17, is it an odd number? Yes, we divide by 2, there's a remainder of 1 there. So as long you divide by 2 and it's not exact, that's an odd number. So 17, 14, 14 divided by 2, that's a 7. So this is not an odd number. 11, that's an odd number. If you divide by 2, you get a remainder. 8 divided by 2, that's a 4. So this is not an odd number. 5 is also an odd number. These are the odd numbers. So they are going to continue like that, and so on and so on. We don't know where are they going to reach. So this is a new sequence of what? Of odd numbers. So from this sequence, you now answer the question. The question is, don't just rush. Understand it. Understand what it is saying. After that now, determine the value of the 20th term of what? These odd numbers. So we need T20 of odd numbers. So this one is no longer there. This one is no longer there. That's why we are even not talking about that Tn. It's not there. We have to find Tn from these odd numbers. And we find what? T20 from there. So is it a linear sequence? Is it a linear pattern? That is the question. Let's find the differences. 11 minus 17. There is a difference of -6. 5 minus 11, there is a difference of -6. Meaning to say there is a common difference. And whenever there is a common difference, it means we are working with a linear pattern where you can use that format Tn is equal to the difference times n plus a certain value, where this is your common difference. So Tn is equal to your common difference minus 6n plus, you need to find this value at any consideration. So you can use T1 because you know that, or you're given that. T1, T2, and so on. So T1, it means n is equal to 1. And the answer is 17. So T1 is 17. When n is what? When n is 1. When this n is 1, you have to find this value. So this is -6. Transpose this side is a +6. So 23 will be equal to the value that you do not know. So therefore, our Tn was going to be given as -6n from that difference plus the answer that we got, which is 23. Or you can use this formula in short, which states that in a linear sequence, Tn can be determined by this formula A plus n minus 1 times the common difference, where A is the first term. So Tn was going to be A, which is the first term. And our first term, according to this sequence of odd numbers, our first term is 17 plus n. We do not know this n so far, but we know D is the common difference, and our common difference is -6. So you have to simplify this. Expand the brackets, minus, and the plus remains as a minus. So it's -6 times n, minus 6n minus 6 times minus 1 plus 6. Add the numbers together after expanding your brackets. You can have 23 minus 6n like this, or you can have it as minus 6n plus 23, just like this. It's up to you. This is how you can calculate your Tn. So you're going to choose which method is easier to work with, that you understand. The method that you do understand. With this Tn, we are going to determine the 20th term, because the question was to determine the 20th odd term. The 20th odd term. So the 20th odd term, it means we are to determine T20 of these odd numbers. So that's a 20 there plus 23. So at the end of the day, this was going to give us minus 97. And as you can see, minus 97 is actually an odd number. It is truly an odd number. So it must be of a surprise that you were told that this must be an odd and you get an even number. It must be of surprise. So this is how you answer this type of a question. You form the sequence of what you are supposed to determine. Is it of odd numbers? Is it of even numbers? You extract the even numbers from the original sequence. You plug out what you're given. What are we given? Odd numbers. Plug out the odd numbers from the sequence. Take them out in the same manner, in the same sequence. Plug them out. As you are plugging them out, you are forming a sequence of odd numbers. Just like that. So you just need to work with many questions, understand these. All right. Consider the pattern. We are given another pattern on 3.3. In this pattern, we are given this as 3A, 10, B, 21. This is what we are given. And they are saying the pattern has a second difference of 1. So meaning say there's a first difference, a second, just like our quadratic. Determine the values of A and B. So we are going to have first the differences, the first differences. All right. So let's find our first differences. Term 2 minus term 1. So it's A minus 3. What is A minus 3? A minus 3 is just A minus 3. You can't simplify that. 10 minus A, 10 minus A is just 10 minus A. No one can simplify that. B minus 10, it is just B minus 10. No one can simplify that. 21 minus B, no one can simplify that. These are the first differences. We got our differences. Then they are saying for the second differences, we were supposed to actually subtract this. This one minus this one minus this one minus this one. But instead of doing that, they are telling us that that second difference is 1. There is a difference of a 1 there, meaning to say the moment that you subtract these two, you are going to get a 1. You subtract these two, you are going to get a 1. You subtract these two, you are going to get a 1. The second difference is common throughout for a quadratic sequence or for a quadratic pattern. So the question is, how can we determine the value of A and B? How? We need 4 marks. We need these 4 marks. How can we have A and B? Okay, if you see properly here, there's nothing that we can get from this part because of where it is coming from. There's nothing. But now, this one that we are seeing here, we know that it is our common difference where we are to subtract this term, 10 minus A minus this term of A minus 3. That is where we got the difference of a 1 because it is the same. So we can form an equation like that. And in this equation, we can see that it is only A that we have. So we can solve for A. It's not a simultaneous at this moment because there's just only A in this equation. Expand your brackets. 10 minus A minus 1 times A, that's minus A minus 1 times this, that's a plus 3 is equal to 1. 10 plus 3, that's 13. Minus A plus 8 means minus 1, minus 1, minus 1. So minus 1 minus 1 is going to be minus 2A. So that's minus 2A is equal to 1. So if we're to solve for A, we're going to transpose this 13 to the other hand. It becomes a minus 13. 1 minus 13 is minus 12. Divide by negative 2. Both sides. So A was going to be what? A positive 6. We just use your calculator. So meaning to say we're going to have A as a positive 6. So how can we find B? We also do the same thing. We go where there's a B. We know that. So we can just take any part where there's a B. All right, you can take this part. This one minus this one must give you a 1, which is fine. You can also take this one. There's something that I want you to see here, which is an equation. All right, this one is going to affect because we do not have A. So, okay, let's just use this one, no problem. Remember our A, we got this as 6. So let's just put in our A here. 10 minus A, remember this was 10 minus A. So 10 minus A, and our A, we got it as 6. 10 minus 6, that's a 4. So meaning you say there's a 4 there. So if you're to do the same thing where a B is, you're going to have the difference of these two to get what? The same one, because that is our second difference, and our second difference on our quadratic pattern is the same. Remember that. Whenever they talk about the second difference, is the common difference. So it means B minus 10 minus 4, it's an equation. So you form an equation, B minus 10, we subtract what from there? We subtract a 4. We must have the same common difference of a 1. So in this equation, as you can see, it's only B that we have. So we can solve for B on this equation now. All right, minus 10 minus 4, that is minus 14 is equal to 1. So B was going to be transpose this. That's a plus 14, which is going to be a 15. So in this case, our B was going to be a 15. Our A as a 6. Just like that. So you see how these questions can be like, they can play around 4 marks for that. So that was our question number 3. 18 marks on everything that we are seeing on this question. 18 marks. So actually under exam, this is what you're going to, you just have to be very, very careful in how you simplify and so on. Just try to be careful in presentation first. The presentation on its own must be perfect. So let's consider this part. Question 4. What are we given? Actually, there's a function. Okay, the diagram shows the graph of f of x, ax squared plus bx plus c. That is the format of a parabola, which is a quadratic function, with the following essential properties, very important properties that you're given there. They gave us a, which is 2 versus y. 2s to y is the turning point of f. So if we check on the diagram, we've got the point A here. So that's our turning point. Okay, we're given the x value at the turning point. B and C, which is minus 1, 0. So the point C is minus 1, 0, and the point B here, these are the x-intercepts. D is the point 6, 7 is a point on F. So D is just a point situated or located on our function F. That is what we have. And this function is a quadratic function, which we are given the format f of x is equal to ax squared plus bx plus c. All right, let's see. 4.1. Write down the x coordinate. That is the x coordinate, supposed to be the x coordinate of B. All right, so the x coordinate of B, that is the x value at point B. The x value at point B. All right, if we were given our, let's say this is quadratic function x squared plus 5x, let's say we are given this. You were going to consider, all right, in the x-axis, y is equal to 0, so this is equal to 0. You solve your equation. But there we are not given the equation. We are just given the format only. So what can we use? Why are we given the turning point? The x value at the turning point. Why? They know that you are supposed to use this concept of the turning point. So I'm going to explain this. Let's hope you will understand me on this one. This one, I just hope you will understand me. All right. So this is the situation. At the turning point here, if we are to draw a vertical line straight passing through the turning point like this, straight. All right, so this one, okay, just a little bit like this, straight passing through the turning point like that, going up. As this line goes up straight, at this point, the x that we are seeing at this point there, this x here, there's xy as a point, is the same because this line that we are seeing is parallel to the y-axis. So throughout this line, which is called the axis of symmetry, throughout this line, x will be equal to 2 throughout the line, throughout. So that can be an advantage. Why? We can take that because at point B, we know that we were going to have the value of x versus the value of y, where we know that along this line, y is equal to 0. And this point is supposed to be x versus 0. We just need to know the value of x. We already know that y will be a 0 there. So don't focus about that. Even here, to this point, at this point, it is 2. It's 2 versus y is 0 throughout this line. Y will be a 0. So don't focus that. Just consider the x. So using the midpoint concept at the turning point, because this is the axis of symmetry. The axis of symmetry, it means it divides your graph into 2 equal parts. So this is the midpoint using the x-intercepts, which are the solutions. It follows that from the solutions, -1, this will be the idea there. So 4.1 using, so you're going to use the midpoint concept. So using the midpoint concept, but just focus with x, we know that the x value of this point to the x value, you're supposed to have x1. This was supposed to be a formula, guys. You know your midpoint. But in this case, what I'm simply saying, already we know the part of y. Don't focus with, just focus with the midpoint. You already know the x at the midpoint is 2. How did you get this? You had to add the x value, this one, which is -1, plus the x value at the point B, which we do not know. Divide this by 2. You are going to obtain the x value at the midpoint. And what is the x value at the midpoint? The x value is 2. So that's an equation for you. Solve that for x. So this is same as over 1. So you can cross multiply. 1 times this, I'm just going to change. 1 times this is going to remain as it is. -1 plus x is equal to 2 times 2, which is a 4. All right, transpose the -1 to this side. It will be a +1. So x is going to be 4 plus 1, which is 5. So meaning to say that at the point B, x, write down the coordinates. Guys, you see the way that I was reading. I don't know now. I think I'm tired, guys. The coordinates of B. I don't know where did I see the x there. All right, so the question was the coordinates of what? Of B. So at point B, we now calculated our value of x, which is what? Which is 5. So meaning to say, therefore, the point B is going to be 5, 0. These are the coordinates of what? Of B. All right, so pardon me, guys, for the way that I had to read the way that I read that one. I said x coordinate is just the coordinates of what? Of B there. 4.2, show that the equation of f can be written as, our equation of f can be written as. So what they are simply saying is that form an equation. You just have to form an equation. So how do you form an equation given this format? It's a parabola. So how do you form the equation? All right. It follows that when given the intercept, the x-intercepts, which are the solutions, because the x value is 5. Remember, this is 5, 0. When given the intercepts like this, okay, because the turning point you do not have, you do not know the y value there. You just know the x value, so you do not have the turning point in full. If you are given the turning point, there's a method for that. But if you are given the x-intercepts, which are the solutions, f of x or y is equal to a into x minus the first solution into x minus the second solution. This is your format. X minus x1 into x minus x2. So it follows that y is equal to a into x minus x1, our x1 at the solution in the y in the x-axis there. What is the x value at this point? It's minus 1. So it was gonna be a minus 1 into x minus x2. Our x2 is the x value also at the intercept, which is a 5. So this is same as we have got minus and minus there. That's a plus 1 into x minus 5, all right? So it's either you're going to expand this or just leave it as it is so that you determine the value of a. So to determine the value of a, you take any point which lies on this function, a complete point where there is x and also the value of y. So we can't use this point because we just have x, we do not have y value. So we are going to opt for the point D, which also lies on F. Remember, we are told that D lies on our F, where we are given this as 6, 7. With the value of x, which is 6, and the value of y, which is 7, we can substitute y is equal to 7 at a point where x is equal to what? To 6. So this is 6. In place of x, you're going to substitute 6. 6 plus 1, that's a 7 into x is a 6. 6 minus 5, that's a 1. So that 7 is equal to 7 times 1. That's 7a divided by 7 by 7. Guys, are going to divide. So a is a 1. So meaning to say, you have got the value of a by substituting any point that you are given which lies on the function. That's why you are given that point which lies on function. So going back to this stage, because we have calculated the value of a, it follows that y is equal to 1, which is our a, into the bracket of x plus 1, into the bracket of x minus 5. 1 times anything just remains as it is, so just like there's nothing there. So if you are to check the format, is just an expanded format. Remember, from your grade 10, if you expand two brackets where there's x and x, you're going to have x squared. So just expand your brackets. So in this case, you have to expand brackets or remove the brackets. All right. So how so? Multiply by x. This is 1 times x, so it's just going to be x plus 1 as it is. So you distribute by x. X multiplies x, that will be x squared. X multiplies minus 5, this will be minus 5x. But then you move on to 1 multiplies x, that will be a positive x. 1 multiplies the minus 5, that will be a negative 5. So meaning to say y is equal to, collect the like terms, that is x squared. Here there's x and x. So these are the like terms in terms of same exponent. So minus 5 plus 1, that is minus 4. So that will be minus 4x plus minus 5, which is minus 5 there. There's just minus 5 on this one. This is it exactly the way that we are given there. This is f of x is equal to x squared minus 4x minus 5, exactly what we are given. So that is what you're being asked to show. Okay, so you can just write as f of x, no problem for that. F of x is equal to x squared minus 4x minus 5. So that is, in this case, they just wanted you to formulate the function, the equation of that function that you're given. They just wanted you to formulate that. But anyways, let's see. Determine the equation of the line hx. They are saying there's a line hx passing through the point C, which is perpendicular to the line passing through point B. Okay, okay. And the y-intercept of f. Okay. The first thing is we need to determine the equation of hx. But this hx, it passes through C, which is perpendicular. It's perpendicular to where? To the line which passes through B. There is a line which passes through B here. Okay, this is it. So be careful how this question was given. They are saying, let us put this way. I'm just going to remove this part. There is a line which passes through B and the y-intercept. It passes through B and the y-intercept like this. It must pass through B and the y like this. The line is like this. So the question is, we are supposed to find the equation of the line from the point C. From the point C, the line as it is drawn, it is like this. To this line which passes through B and what? The y-intercept here. So this is the line that we want to find its equation, which is perpendicular to this line which passes through B and the y-intercept. They're saying, okay, let's go back. The y-intercept. The y-intercept of f. The y-intercept of f. So it must pass through the y-intercept of f. So if we take this, guys, my sketch is not going to be fine. If we take this way, let's just hope I'm going to be able to remove this. It must be through the y-intercept of what? Of f. Okay, let's just hope we're going to win, guys. Very sorry. Okay. So let's do it this way. The y-intercept of f is here, so it must be like this. The y-intercept through B like this. All right. So the line must pass through the y-intercept of f and also pass through B. So we want the equation of the line perpendicular from C. So from C, it must reach this line at what? At 90 degrees. This line which passes through the y-intercept of what? The y-intercept of f and also through B. So the question is, we need the equation of this line. I mean, the equation of this perpendicular line, this one. This is the perpendicular line, this one. This is our hx, this line. So we need to determine this equation. How can we determine this equation? Okay, let's focus on the concept that we are given that they are perpendicular. Okay, so if they are perpendicular, we understand that the gradients of these two lines must be a -1. So this is our 4.3. I'm not mistaken there. Let's check. That's 4.3. All right. So if two lines are perpendicular, the products of the gradients must be a -1. So the question is, are we having the gradient of this line, or can we have the gradient of this line direct? We can't have the gradient of this line direct because we do not know where this line it is going to pass this line from B. But we know that the line from B passes through the y-intercept of what? Of f. So if it passes through the y-intercept of f, we can determine the point here at the y-intercept of what? Of f. So what is the y-intercept of what? Of f? Because we are told that it passes also, the line from B passes through the y-intercept of f. And remember our f of x, the one that we calculated before, we got this as x squared minus 4x minus 5. Remember from our calculation, this was x squared minus 4x minus 5. And the y-intercept, we know that x must be equal to what? X must be equal to 0. So if x is equal to 0, it follows that y is equal to minus 5. So this point here is minus 5. That's 0, minus 5. Y-intercept x is 0 there. So we can take advantage of this point B because we know the point B before. The point B, remember, is the first point that we calculated, which was 5, 0. So we can calculate the gradient of this line from B to C. Our gradient, remember from our formula, y2 minus y1 over x2 minus x1. It follows this gradient. The y value, that's a 0 there, minus the y value, which is minus 5. So it's 0 minus 5 over x2. The x value here is 5 minus the x value at this point, which is a 0. So this will be positive 5 over 5, which is 1. So that's 5 over 5, that's a 1. So the gradient of this line is 1. And we are saying for perpendicular lines, the gradient of the first line times the gradient of the second line must be equal to negative 1. So from this line that we are given, B, which passes through the y-intercept, its gradient is 1. What about the gradient of the second line, which is the one that it is perpendicular to, the one for hx? What is its gradient? We do not know, but we know that their product must be a negative 1. So if we divide by 1, it means the gradient of the second line is minus 1. And the second line I'm referring to hx. So let's say this is our first line and hx is our second line. So we have now the gradient of the second line, which is the gradient of what? The gradient of hx. We have it as minus 1. And hx passes through C. So if hx passes through the point C, given as minus 1, 0, we can determine the equation of the line. Why? Remember, the equation of the line is given in the form of y is equal to mx plus c. That is the gradient intercept format, where m is the gradient, and we calculated the gradient minus 1x plus c, where you can calculate c from the point that you're given, which lies on that line. Y is equal to 0 when x is minus 1. That's minus 1 times x, which is minus 1 plus c. That's a positive 1 here. So that's a positive 1. So transpose this, it will be a negative 1 is equal to c. So if c is negative 1, therefore our equation is going to be what? Minus 1x plus c, which is simply minus x plus c, which is minus 1, plus minus 1 is a negative 1. So we have got the equation of this line hx. So that is y is equal to mx plus c, which is minus x minus 1. That was the consideration, just like that. Just like that. You just have to understand your functions. For which values of x is going to give us a value greater than or equal to 0, the product of x to f of x. Okay, the product of x to f of x. Our f of x is the function that we have here. So if you are to multiply this, it is simply a consideration like this. Remember, we have got the solutions where x is what? Minus 1 and a 5. So this one, you can go back to your inequalities, the product of x times f of x. Our f of x, don't worry about it, but we know that the product of these two that we are talking about, x and f of x, when you were to solve for an inequality, you were going to look for the critical values, which are conditions where this is equal to 0, you solve. So x at that moment was going to be 0, or f of x must be equal to 0. And when f of x is equal to 0, that is where we have these solutions on our graph. Minus 1 and what? And a positive 5. This is where we have our solutions at minus 1 and what? Minus 1 and positive 5. So we also have x, which is minus 1, or x, which is what? A positive 5. So at which point that you are going to take the x value and you multiply it to the y, to the f of x, so that your values will be what? Greater than. So it's actually a trial and error that you're going to take between your values. All right? It's a trial and error that you're going to take between your values. But you're going to see that within these values of -1, because you were given this, I want you to check your f of x. This is your f of x here. I want you to check. X is a certain value. Let's take a consideration to say these are boundaries. Let's hope you understand me, guys. This is -1. This is a 0. This is a 5. There are values which are less than 1, which are this side. These values, they are less than 1. Think of a value which is there. Let's say -2. All right, I'm just taking a consideration. Let's say -2. Okay. If we take values which are less than -1 on our graph here, values which are less than -1, this is where we have -1 on our graph here. It's a critical value. That's why it's there on our graph. Values which are less than -1, these are the values here, these ones. X values -2, -3. What is the function? How is the function presented on these values? From these values, -1, are we seeing that the function is above the x-axis? It's on top of the x-axis. So when this function is on top of the x-axis, it means our f of x is what? Is positive. Our f of x is positive. From -1 going this side, your f of x is going to be positive on top like that. It is going to be positive. So let's go back now and conclude. Does it satisfy this condition? Because we are saying when x is -2, these are values which are less than -1. F of x at that condition is a positive value. This is your f of x, this one. But take note, there is an x which is multiplying your f of x. And your x now, because our x is less than -1, so we can take any value, maybe -2. So if you take a minus, it's a minus, this one. So your x is a negative value. So a minus times a positive, because your f of x, remember, when we interpreted from the diagram, our f of x was what? Positive. So negative times positive, what do you have? When a negative, we don't need to know the value, we just need to know, is it going to be positive or not? So negative times positive is a negative. So what does it mean? A negative, these are values which are less than 0. But here they are saying, if you take that x that you are thinking of in that interval, and you multiply it to the output, which is your f of x, your values must be greater than 0. And to be greater than 0 means these values are positive. But this one, it is giving us a vice versa. It's a negative. So meaning to say, for all values which are less than -1, for all values less than -1, there is no solution there. There is nothing to take. There is nothing to take. So there is no answer there. There is no answer. There is nothing. There is no solution. So you move on. Again, our x and f of x. So we interpret from -1 going this side. These values, they are greater than what? They are greater than -1. So the question is, are we going to take from -1 to 0? Are we going to take from -1 up to 5 straight? We have to interpret with what we are given from the diagram. Okay, so let's interpret from -1 to 0, what is happening? From 0 to 5, what is happening? So that we know, is it the whole function that we are taking or not? All right. I'm just going to erase this part here. I'm just going to erase this part here. All right. So this is where -1 is, and this is where a 0 is. All right. From -1 to 0, we can't use that to say, we know that it was supposed to be values in between here. How do you write them? X is greater than or equal to -1, less than or equal to what? Less than or equal to 0. These values, they are in within -1 and 0. But as we check now on the output of our function, because this is where we are at -1. On the output, when I'm saying on the output, I'm saying on this graph of y, this one, on this graph. If we check from -1 here, it is now below the x-axis here. At 0, it is also below. It is also, it is here also here, guys, everywhere, up to here, up to b. This function that we are seeing, our f of x, from -1 up to 5. Remember at b here, at b it's 5. From -1 up to 5, including even the 0 there. Including it. Including even the 0. Our function is what? Is a negative. But because a 0 is a critical value, so we can also separate that. So it's either we are going to separate or we take it from -1 to 5. There's no problem. All right. But we have to consider that as a critical value, the function is still operating in the negative, guys. This is what I'm saying, from -1 up to 5. So this is what we have. Our f of x is in the negative. Take note, it is below the x-axis. This is our x-axis here. It's below the x-axis. So whatever that is below the x-axis, it means it's a negative. If you substitute anything within this region, your answer will be negative on f of x. Okay, this is what I'm trying to say, guys. Don't confuse. Let's take our f of x. Where is it? This one. You understand me. You definitely understand me. This is our f of x. I want you to test any value. Your f of x, which is y, is equal to x squared minus 4x minus 5. Just take any value from -1 to 5. We can't take -1 and 5 because these are critical values. You are going to get a 0 there. So use any value. You can choose 1, you can choose 0, you can choose 1, 2, 3, anything. Okay, let's take 1. Substitute 1 here, substitute 1 here. This is going to be 1 minus 4 minus 5. And you are going to get something like 1 minus 4 minus 5, which is -8. Why there is a negative? Take anything, move on to 2. When y is 2, you substitute 2 squared minus 4 times 2 minus 5, anything that you want there, you are going to get a negative answer there. You will get a negative. So it means these values, they are negative. F of x is negative. So let's interpret now. So we said we are going to take from -1 to 5 and this interval. So between -1 to 5, how do you write this solution? You can write it this way. This is how you can write it. X between -1 to 5, also 0 is there. So these values, they are greater than or equal to -1 because it's a boundary now. All right. Great. This is greater than or equal to -1, but less than or equal to what? To 5. All right. Why are we not taking greater than this other side? Because from 5, if you check from 5, our function is now above the x-axis. It's another region. So you have to work it on its own. Just like what we did this side, it was on its own. So you work with region by region, region by region. So this is your f of x here, this one. It's a negative, it's in the negative region. Okay, so let's interpret. Our f of x is in the negative region from 0 to 5. All right? Our f of x, remember the question is supposed to be what? We are interpreting here. The product of x times f of x is supposed to be greater than or equal to 0. All right. Our f of x in that region, it was a negative. Okay? This is our f of x. We saw that it was going to be a negative. Then we are taking any value that we have from here. We are going to take any value from here. All right. So let's take a consideration of a -1. If you take a -1, you are going to take a -1 there, a -1. As a critical value, you're going to see negative, negative. That's a positive. We are at 0 there. From -1, you're going to see that -1 minus up to 0. These are negative. So in every negative is going to give you a positive, meaning to say a positive is something that is greater than or equal to 0. But now as we move on to from 0 now, let's take when it is a positive, this one, our x now is a positive. Let's take any value from 0 to 5. From 0 to 5, we can take when x is 1. So when x is 1, you multiply, it's a positive, this one. You multiply to f of x. Remember, the f of x is still in the both. Remember, I combined everything. F of x is still in the negative, so it's negative there. Let's see what we're going to have. Positive times negative gives us what? A negative. It is no longer a positive. So meaning to say, from 0, from values that are greater than 0 up to 5, because 5 is a 1, 2, 3. All these values of x, they are positive. Because what controls at the end, guys, is that we are supposed to multiply by x. So we also have to interpret with x also. So x times f of x, which is a negative. Negative times negative is a positive. A positive is a number that is greater than 0. So meaning to say, from -1 to 1, if you take any x value there, it is a negative. So negative times negative, you get what? A positive. So we are going to take everything. This one, it's part of our solution. From -1 to 0. X must be greater than or equal to -1, less than or equal to 0, because there's an equal sign there. That is why we have to put this. But if we check along the same interval from -1 up to 5, where we were considering our f of x. But the moment we move from 0 now, it is not going to work, because these numbers, they are for x. So if you take any x there, it will be a positive. Positive 1, positive 2. So positive times negative gives you a negative. Remember before I said this region failed because the resultant was a negative. We are supposed to get a positive if you multiply both x and f of x. So that's how you interpret. So from 0 to 5, there's no solution there. There's nothing. So this is our first solution. We move on. That's our first solution, this one. We move on to the other one. Which other part is left now? From 5 going onwards. These are values which are greater than or equal to 5. So let's interpret what is happening on our diagram. These are values which are greater than or equal to 5 on our diagram. All right, let's just remove this. Let's not be confused with a lot of information there. Let's hope guys will be able to finish up, because you know these softwares, they tend to misbehave when you record a lot of things. All right, like I said, let's interpret from 5. From 5, our function is above the x-axis, meaning to say our function is now positive, just like what it was before here. Our function was positive, but what made us not to take this, it is because of the x value. The x was negative. Even though our function was positive, we are going to get a negative answer, which is wrong, because we want a positive answer. So this time, let's interpret. Our f of x is positive, just like what we had this side. It's above the x-axis. All right. So this is it. From that interpretation of values which are greater than 5, x times f of x. Our f of x, we said it is what? It is positive. Okay, what about x? If we are talking about values which are greater than or equal to 5, are these values positive or negative? They are positive. 5, 6, 7, 8, 9. These, we can't have a negative there. These values will be positive. So this time there is positive times positive. What do we get? A positive. When it multiplies a positive, you get what? A positive. That's how you interpret. So meaning to say this is correct. We want it because we want something greater than or equal to 0 after multiplying these two. After multiplying these two, we must get a positive. And this is exactly what we are having. So meaning to say values greater than or equal to 5 are also part of our solution. So also our x was going to be what? Greater than or equal to 5. Can you interpret that? So if you are now used to these functions, you won't even like do like this. You just say, okay, just look on your diagram. Okay, this is happening. You just look on your diagram. But I'm explaining this so that we all understand. So that is it. You can just interpret on your diagram. Is it what is it that is happening from year to year? If I multiply by negative, okay, it's negative. I leave it. I move on from -1 to 0. I move on from 0 to 5. I move on from 5 going onwards. Straight from your diagram, you can do that. So that was it. 10 marks on everything on this question. That is how they can ask these questions. Just have to be careful from there. Question number 6, question number 5, I mean, given gx, which is 6 over x minus x plus 2 minus 1 and px. Sketch these graphs, show clearly the asymptotes. We need the graph of g. All right, we need gonna show clearly the asymptotes and the intercepts with the x's. 3 marks for that. All right, so this is our gx, the first one, 5.1. All right, so we need to sketch this graph of gx. And gx is given as 6 over x plus 2. This is a hyperbola, remember? On our hyperbola, if we are given f of x is equal to a into x plus p plus q. Let's say you wrote this way. It means that you're going to take this x equal to 0. It means it will be minus p versus q, like that. So this minus p versus q is the point which is at the asymptotes, meaning to say x is equal to minus p at the asymptotes and y is equal to q at the asymptote. That is something that you just need to know. So meaning to say for the equations or of the asymptotes, you just equate this to 0. X plus 2 is equal to 0. So x is equal to minus 2. The y value, as you can see, y remains as it is. Y is equal to q. It remains as it is, meaning to say y remains as it is from your equation. So we have the asymptotes. This is where the graph is not going to pass. So we are going to need the x-intercept. All right, the x-intercept on a condition that we know that it must be y is equal to 0. So if y is equal to 0, what are we going to have? That's 0 is equal to 6 over x plus 2 minus 1. Solve this, transpose the minus 1 this side, that's a positive, which is equal to 6 over x plus 1. 1 as a fraction is same as 1 over 1. So how can I calculate for x? I can just cross multiply 1 times x plus 1. It remains as it is. X plus 1 is equal to 1 times 6, which is 6. So if we had to transpose the 1 to the other side, that would be a minus 1 on the other hand. So that means x is going to be 6 minus 1, which is 5. So this is what we are going to have at the end. This was x plus 2, guys. You see now the way that I'm saying this now, your teacher is now tired. This is x plus 2 here. So that's x plus 2 here. So it will be 6 minus 2 and 6 minus 2. Let's correct this one. That will be a 4. Okay. So that is x is equal to 4. So that will be our x-intercept, 4 versus 0. The y-intercept, with the same consideration, we are going to see that for the y-intercept, the condition is x must be a 0. So y is equal to, in place of x, you are going to substitute what? A 0. In wherever there is x, you are going to substitute a 0. So that means y is equal to 6 over 0 plus 2 minus 1. So on this one, there is no transposing, there is no this and that. Just use your calculator as it is. It's going to be something like a 2 there. So that will be 0, 2. All right, remember the x value, that's a 0, and the y value is a 2. So you can just write the coordinates. Then you can sketch your graph. Remember, this is a hyperbola with the idea of a graph that you are to sketch. You can sketch any function that you're asked as long you have the knowledge or the idea of that function. So we understand that a hyperbola is going to be something of this with our x and y axis. We are going to need first the asymptotes. So let's just say that's 0 here, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, and so on. All right. So what you're just going to do is to mark your points and so on and so on and so on. All right. So first thing are the asymptotes, because that is where our function, where the function does not operate. The function does not operate when x is equal to 2 and when y is equal to -1. Remember your asymptotes. So x is -1, y -1. So this is x, which is -1 at this point. So where x is -1, what you're just going to do is to indicate a vertical line. Hey guys, you see where I am I'm reading exactly -2, but I'm saying -1. Guys, sorry for that. So this is x, which is equal to what? -2. So we've got x, which is -2, y, which is -1. Y is -1 here. So you draw a horizontal line straight to pass through the -1. So it's an asymptote. You can even use your continuous lines. I'm not saying you're supposed to use a broken line. So this is y is equal to -1. I just want you to properly see. So these are the asymptotes. So with this, you are going to mark our intercepts. According to this, we've got the x-intercept at 4 versus 0. 4 versus 0 in the x-axis at 4. 0, 2 for the y, which is 0, 2 here. So they are just 2 points that you're given, and they are just on the same side. So with the value of a that we are given, it's a positive. We know that we are supposed to have a shape this side and this side. But they were just given 2 points, the y-intercept and the x-intercept, and they are both on the on one side of what? Of the function. So if you were to join your function like that, guys, okay, so it's going to just stretch a little bit, just something like this. All right, going like that, tending to approach to y is equal to what? -1. We know that we are supposed to have 2 pieces. So the other piece is supposed to be in this region, this one. It cannot cross these asymptotes. So that is why we do not have the x-intercept. That is why we do not have the y-intercept. So our function is just going to be within this region. You have to indicate that, because you know the hyperbola, they are supposed to be 2 strips, one this side and the other one on this side. So this is our G, just like that. All right. You are done. Determine the equation of H. All right. Determine the equation of what? Of H. The line of symmetry of G that has an angle of inclination of 135 in the form of y is equal to. That is, we're going to choose the y is equal to mx plus c format. So they are saying we are supposed to determine the equation of H, the line of symmetry of G. Remember that whenever you're dealing or you're working with a hyperbola, the line of symmetry is found at or is drawn or is actually found from where? from the asymptotes at the intersection of the asymptotes. All right, we do not know, is it gonna pass through which point, but yes, just a sketch guys like this. These were supposed to be our lines. But in this case, we are not going to work with both lines because we are told this one, it has an angle of inclination of 135 degrees. It has the angle of inclination of 135 degrees. So we can't say this line has got an angle of inclination of 130, because guys, this is an acute angle, this one. So this is not the one. The one that we are talking about is this one with an obtuse angle, the angle of inclination between the line and the positive side of the horizontal axis. So this is the one that we are talking about. So let's say this is our theta. So meaning to say, if this is the one that we are talking about, we need its equation now. So this one is not there. I'm going to remove this. So we are going to need its equation. So the question, how are we going to determine the equation? For the equations of these lines, the axis of symmetry of a hyperbola, there are just two things that you need to take into consideration. All right, I want to remove this, guys. Let's just hope you win. All right. Okay. Okay, sorry for that. So this is it. For the equation of these two lines, remember with this one that we removed with a positive gradient, there are just two formats for the equations of your axis of symmetry. Which formats? It's either it is of y is equal to x plus c or y is equal to minus x plus c. So that is for there. So the 135 there, just telling you, is the one with a negative gradient. Even if you have to use a calculator, tan 135, remember, gradient is equal to tan the angle of inclination, which is theta. So you can use that tan 135 degrees. You are going to see that you're going to get a negative one. But that is not even important. Here, that is the important. So this was just to tell you that which one are you using, the one with a positive gradient or with the one with a negative gradient. So this one, it is the way that it is slanted. Remember, all lines like this, they have got what? A negative gradient. So meaning to say the one that we are going to use is the one with a negative gradient. Y is equal to minus x plus c. But I said these two lines, they do pass whether it has a positive gradient or not, they do pass at the point of intersection of those asymptotes, where x was minus 2. Remember, at asymptotes, x was minus 2 and y there was minus 1. So you use that to determine your equation. Y there is minus 1 when x is given as what? As minus 2 plus c. So that's minus 1 is equal to a 2 plus c. Transpose this, that is going to be a positive, a negative 2. Minus 1 minus 2, that is minus 3. So c is negative 3. So therefore, our equation was going to be y is equal to minus x plus minus 3. That will be a minus 3. Just like that. So this is our hx. Remember, they told us that this is going to be given, or is going to be written as what? As h. So we have got the equation of hx. Let's just remove, guys. There are not a lot of things. I don't trust these boards. They just tend to misbehave if there are a lot of things on them. So let's see so that we do not miss anything up to the end. All right, in this case, we calculated this. So this is our hx, which is the axis of what? Axis of symmetry with a negative gradient. So our hx was negative x minus 3. So it means it passes through the y-intercept at negative 3. Okay, it's another thing to consider. All right, so let us check what we have so that we conclude our question. Very sorry for that. I'm just gonna remove this one or two things here just to minimize. All right. So this is it. 5.3, determine the values of x for which gx is less than hx. So this one, you can interpret it from the diagram. Where gx is less than x, it's a condition where gx, because it's less than, it is below hx. When it is a greater than, you take when it is above. All right, when you take it when it is above hx. But this one, because it is less than, we want every part where gx is found below hx on our graph. Where is it? That's 5.3. Where is it? So gx is less than what? hx. This is it, gx. That's 5 points. So this will be 5.3. We want a condition where gx is less than what? hx. So like I said, this one is less than this, so it must be below hx. So where this is our g, the hyperbola. So if you check along this region, this one, along this region, our g is below this graph. It is below. It is the one that is below. Along these values where x is limited at -2, where x is less than -2, -3, -4, -5, all these values where x is what? Less than -2. Our gx is below. It is below hx. But if you move from that region of -2 now, this side, -2, above, -2, -1, and so on, you will see that your hx is the one that is on top of what? On top of hx. Our g is on top, so we can't take this region. So that was the only solution. X must be less than -2. X cannot be equal to -2 at their asymptote. So x is less than -2. So it was going to be a vice versa if they said gx is greater than hx, meaning to say our values were going to be what? X is greater than 2. But in this case, our x is less than this. Okay, so be careful. Be careful how you're going to attempt this one. And this x is going to be an element of all real numbers that we're going to talk about. So that's it. Then if the graph of gx is shifted so that it coincides with the graph of P, by how many units must this graph shifted horizontally? So this is it. Our graph of hx is here. They are saying we are going to shift until it looks like this one. So how many units are we going to move until it looks like this graph of what? Px. Horizontally. Horizontally, these are the x values. So what happens is that when you are dealing with the x values, which is horizontal, before at px, we have to transform. It was x plus 2. So you must ask yourself, how many units are we going to move so that this will be what? A -3. So that it will be a -3. How many units are we going to move so that this will be a -3? Because it's a -3. How many units are we going to move so that it will be a -3? So this is it. If we are to consider this, we are going to move how many units to get a -3? It means this was a -5. X plus 2, we subtract a 5 like this. So 2 minus 5 is what? -3. So it means we moved how many units if there is a -5? So take note, a horizontal shift, it affects this way. Just like how you calculate their asymptotes. When it is x plus 2, you say x is equal to what? -2. Why? And when it is y, you use it as y is equal to -1. There's something about x. It opposes the way it is given there. So if you are saying x there, it's a -5 on the presentation, this is not your x. No, this is not your x. The x that we are talking about is when you solve, just like when you have x plus 2, you find x is equal to 2, -2. So it means if x is -5, it's going to be equal to 0. So x is equal to 5. So we moved 5 units. So meaning whenever you see a negative, you write the opposite way. It means these are 5 units to the right. To the right, because we saw at the end, x is going to be a +5. So meaning to say is to the right. So when you see an expression like this, x -5, it's 5 units to the right. Don't consider this negative. But if x is equal to 5, it's already telling you where x is going. There you don't change anything. X is 5, you're going to the right straight. It's not an expression, that one. All right, so be careful. What about vertically? Vertically, we consider the y values now. It was at -1, now it's at 2. So how many units did we move from -1 until we get to 2? So it's simply 2 minus -1. We moved how many units? 3 units going up. So these ones are 3 units up. Y is 3 units up. That is vertically. Vertically, you consider how are you moving in the y-axis. Horizontally in the x, but you have to be careful on the horizontal. As you can see, there are a lot of things there to consider on the horizontal. There are a lot of things there. Question 6. Given hx is 3 into 2 to the exponent of x -1, this is our exponential function. So we are given this hx, write down the equation of the asymptotes of h. Remember, when you're given an exponential function, the asymptote is the y value. So our asymptote, it's y is equal to -6. Then the x-intercept of h, the x-intercept, it's on a condition where y is equal to 0. So 0 is equal to 3 times 2 to the exponent of x -6. You solve for what? For x. That's your x-intercept. Y is equal to 0. So if y is equal to 0, you can solve this. Transpose -6, it becomes a +6. 3 times 2 to the exponent of x, you can divide by 3 since this is a multiplication. So it follows that 2 to the exponent of x is equal to what? To 2. Since this is invisible, the exponent, it means there is a 1. And we know that if the bases are the same like this, we equate the exponents. As long the bases are the same, the exponents are the same. So it follows that x is equal to what? X must be equal to 1. So that's our x-intercept. That's 1 versus what? 1 versus, remember, y is 0 there. Okay? From there, they are saying, determine y-intercept of x. So the y-intercept, it's on a condition where x is equal to 0. So that one you can just substitute into your equation straight. Y is equal to x. It's a 0 there. So it's 3 times 2 to the exponent of 0 minus what? 6. So simplify this on your calculator. That was going to be -3. So that's 0 versus -3. That's your y-intercept. Determine for which values of x is hx greater than 0. So this one is an inequality. So already on the inequality, we do not know, or we haven't drawn this function. Whether you're going to draw your function, it's up to you. But we need a condition where this function, which is our f of x, which is our hx, I mean, the one that we are given there, where it is greater than 0. Where is it greater than 0? It means 3 times 2 to the exponent of minus is supposed to be greater than 0. As we know, each and every inequality you solve for the critical values, and the critical values are the solutions when our f of x or whatever function that you are given at that moment when it is equal to 0. And when hx was equal to 0, we solved this before. So you're not going to solve again. You solved and you got that x is equal to 1. So at x is equal to 1, that's a critical value. That's a critical value, meaning to say at x is equal, if you substitute a 1 here, you get a 0. Your hx is equal to 0 when x is 1. It's a critical. But we want a condition where hx is greater than. So since you have a critical value, you can use that to balance now your solutions to check how are they going to be related. There's only one solution. There's only one critical value. So meaning to say there are just two answers that we expect. Which answers? Values that are less than 1 and the values that are greater than 1. Because x cannot be 1. Because where x is equal to 1, that's a critical value. We cannot take that one. So we need a solution where it is less than 1, where it is greater than 1. So it is like, it's in your hands when it is like that. A question like this, it's in your hands. You can just use your simplification, substitute any value that is less than 1. Think of any value less than 1. Let's say we put a 0 there. Any less than 1. Put a 0. Any value less than 1. So if you were to substitute a 0 there, you are going to get a negative value. A negative value, is it greater than 0? Okay, this is what I'm trying to say. Substitute any value of your choice that is less than 1. So like I said, I'm going to substitute a 0 there. 0 is not a critical value. A critical value is 1, not 0 from our solutions. 0 is not a critical value. So guys, just because of these softwares now, it's difficult for me to even show you what I want you to see because of this time. You see these softwares, guys, they want you to work for a certain time. Okay, but this is what I'm trying to say. I'm going to substitute here. This is 3 into our, okay, let's just do it like this. 3 times 2 to the exponent of x. Just going to choose any value of our choice there. So we said if x is a 0 there, okay, minus 6. So we check, it's a negative 3. So is negative 3 greater than 0? No, it's not. So this is not a solution. We move on to this one. When x is greater than 1, any value greater than 1, you can choose when x is 2. It's greater than 1. Let's substitute and see. Where there was x, yeah, this is where our x is. Okay, sorry for that, no problem. Let me just rewrite it again. Remember, that's 3 times 2 to the exponent of, we are saying our x must be what? A 2. 2 minus 6. So for any value that you're going to take there, you are going to get positive values. 6 is greater than what? 6 is greater than 0. So meaning to say this solution is true. So therefore, our x must be greater than 0. Must be greater than 1. I mean, where x is what? Where x is greater than 1, our f of x, I mean, our hx is going to be greater than 0. Meaning to say our hx is going to give us a positive answer for all values of x. Think of any value of x greater than 1. Think of any, put it here and see. Are you going to get a positive or not? Also, think of any value that is less than what? Less than 1. Substitute it here and see, are you going to get a value greater than a 0? If not, then it means it's wrong. There's no solution there. All right. There's no solution. Then we are given on 6.2, draw a neat sketch of the graph of, again, it's a exponential function, this one, but we are given this as gx this time. So they are saying gx is given as a times b to the exponent of x plus q, where a is equal to 1. So this is gx is equal to a is 1 times b is a number that is greater than 0 but less than 1. So meaning to say b is any decimal that you can think of between. It can be 0, 2, whatever value that you want. So this one is your choice, just any value of your choice, just to consider how the function, but we know this is our b. We just want to see what's going to happen. And x is, we do not know. Remember, x, we do not know this one. And q is -1. So this is our function. How do we sketch the function of this nature? Maybe 0, 2 to the exponent. As we can see, guys, this is an exponential function. But because it's a decimal, it means it is going to, okay, the first thing, the asymptote is what? -1. This graph cannot pass through -1. So remember what we had before on the asymptotes. So this is our x, this is our y. So the asymptote is going to be at -1. That's one thing that we are sure about. Y is equal to -1. So you're going to find your x-intercept and so forth. If we were to check, if x is equal to 0, there we are going to have what? If x is a 0, there you're going to have 1 minus 1, which is a 0, meaning to say, when x is a 0, this function was going to pass through the origin. When x is a 0, it's no longer passing through a 1, just like what we are used. When x is a 0, think of any value you put here, any number to the power of 0 is what? 1. And 1 minus 1 is a 0. So meaning to say, where x is equal to 0, it was going to be a 0. So that is the most important part. And this being a positive is for the shape. The shape is supposed to be like this. So your shape was going to be like this, passing through the x-intercept, which is 0, 0, and so on, tending to approach the y-axis, but it won't approach this y-axis. So this was going to be our G. Just a sketch. Just a sketch. So the x-intercept is on a condition where y is equal to 0. And the y-intercept, it's on a condition where x is equal to what? Where x is equal. So in the same manner, you are going to blink, they were going to go back to the what? To the 0, 0. So these are the typical questions normally for your June examinations, like these ones, depending with the province that you are from, but you are supposed to be very, very careful in the simplification. In these questions, they are very, very similar because at the end of the day, they want you to have the same thing. So that means revise as many questions as you can to make sure you are equipped for the exams which are ahead of time. But that's it, guys, for now. Till we meet again.